Hi everyone, welcome to T1 Academy. So, as you know, for the upcoming UPSC Prelims examination at T1 Academy, we are conducting marathon sessions. So, as part of that, I am dealing with geography. So, in the previous session, we have detailedly discussed about the atmospheric composition. Prior to that, we also discussed the climatic, the reasons, the climatic factors that influence the climate of a region. Okay. Now, in the present class, we will be discussing about the atmospheric structure. Atmospheric structure. You all know what is atmosphere, right? So, atmosphere is nothing but it is mixture of gases surrounding the earth surface. Okay. So, your earth surface, the earth surface is covered or enveloped by mixture of gases and we call it as atmosphere. Water on the earth is called as the hydrosphere. The frozen part of ice, that is the polar region, this comes under the cryosphere. Life comes under biosphere, and the upper part of the earth surface is about lithosphere. So we have these 5 spheres of life, right? Major spheres: lithosphere, hydrosphere, atmosphere, cryosphere and biosphere. Okay. So climate has all interactions with this. Okay. So what is atmosphere? Atmosphere is nothing but mixture of gases. So this mixture of gases surrounding the earth surface, and these gases are held by the gravity of the earth. They are held by the gravity of the earth. So that's why density of the gases is maximum near to the earth surface, and as you move to the upper layers of the atmosphere, the density of the air decreases. Okay. Now what we are talking, that the structure, that the atmosphere covers the earth surface, right? Now within this atmosphere there are layers based on temperature and their properties. They have been divided into different layers. Let us see what are that layers. Okay. So if you consider this is your earth surface, if this is your earth surface, and from earth surface to around 300 and 400 kilometers above, you have atmosphere. Okay. Anyways, as I told you, as you move to the upper layers, the density of the air decreases. Okay. So first, if you come close to the earth surface, the first layer that you see close to the earth surface is the troposphere. Above that you have stratosphere, then above that you have mesosphere, and above that you have thermosphere, and beyond that is called exosphere. Okay. So totally we have around 5 layers. So atmosphere can be studied with layers based on their temperatures and properties. Okay. So atmosphere is nothing but mixture of gases surrounding the earth surface, and this atmosphere can be divided into 5 layers: troposphere, stratosphere, mesosphere, thermosphere and exosphere. Okay. And on what basis we are dividing it? We are dividing on the basis of temperature and its properties. Okay. So let's start our topic with troposphere, since it is first layer of the atmosphere. Okay. So the first layer of the atmosphere from the earth surface, it is troposphere. Okay. Now the troposphere, the variation of the troposphere, I mean the length, or you can say the thickness of the troposphere, varies from point to point on the earth surface. That means on an average we say that the troposphere extends from around ground surface to 10 kilometers. This is an average, 0 to 10 kilometers. So earth surface to 10 kilometers you have troposphere, but this is average. So 10 kilometers thickness cannot be seen everywhere. Getting my point? Now where do you find this thickness, maximum thickness at, and where you find the least thickness? See, so the maximum thickness of the troposphere, can be seen in the maximum distance thickness of the troposphere can be seen at the equator. Okay, and the minimum thickness can be seen in polar regions, the North Pole and South Pole. Why? Because you know that the equator region, the air is warm because of the direct run rays, this region. So air expands and moves upward. So that's why the thickness at the equator is maximum. So it may go up to 0 to 20 kilometers. Okay, 18 to 20 kilometers. And whereas in the polar region, the thickness is very low, So the thickness of the troposphere is less than 8 kilometers or so. Okay, so that's why on an average we say that the thickness of troposphere is 10 kilometers, but actually it is maximum at equator and minimum at poles. Why? Because of temperature difference, right? This is the point you have to remember. Okay, troposphere. So in generally we say the troposphere extends, goes up to 7 to 20 kilometers. Okay, so here once again the point you have to remember is that tropo means change. Okay, so why it is called change the layer? Because all the weather related phenomena takes place in the troposphere. Your cyclones, formation of clouds, precipitation, condensation, all these phenomena is associated with the troposphere. All these activities takes place in the troposphere. So that's why it is called the tropo means change, since all the weather changes occur in this layer. Okay, and you can also see the maximum dust particles, water vapor concentration can be seen maximum in the troposphere, and if you move to the higher layers of the atmosphere, you do not find the much water vapor and the dust particles. Okay, right. The most important point that you have to remember regarding the troposphere, that with increasing the elevation, with increasing the altitude in troposphere, the temperature decreases. The temperature decreases. So on an average, for every 165 meters increasing the elevation, the temperature drops by 1 degree Celsius. Now why this happens? Why? See, most of the students get your doubt that if you are moving to the upper layers, that means you are coming close to the sun, right? You are coming close to the sun. Then why temperature decreases? So if you are moving to this air, that means you are coming close to the sun, right? So temperature should increase. As you move to the higher layer, the temperature should increase. But why the temperature in troposphere it is decreasing? This is the point here. So yeah, see, you all know sun is a source of light and heat for us. For all 8 planets that we have in the solar system, sun is a source of heat and light for us, right? So the sun, the incoming radiation from the sun is called insolation. The incoming radiation is called insolation. Incoming solar radiation is called insolation. So remember that this sun heat that is coming from the solar radiation will not heat up the atmosphere first. Okay, the sun radiation will not heat the atmosphere first. Instead, it heats up the earth first, the earth surface first. Getting my point? The radiation coming from the sun is absorbed by the earth first, not the atmosphere. Okay, so observing the radiation from the sun, the earth receives the heat, okay, and it starts radiating heat, and this radiation is called terrestrial radiation. This radiation is called terrestrial radiation. Getting my point? The solar radiation which is coming from the sun will not heat the atmosphere first. First the earth surface gets heated up, and once the earth absorbs the heat, and then it starts heating, then start releasing radiation called as terrestrial radiation. So the atmosphere will not be directly heated by the sun's radiation, it is heated by the earth radiation. So that's why the layers close to the earth, are always warm, because of the heat. So these layers, the atmosphere gets heat from the earth radiation. So as you move to the higher layers, as you move to the higher altitude, what happens? Temperature drops. Why? Because these layers are not close to earth. So as you move to the upper layers, the radiation effect will be low. So that's why in troposphere, with increasing elevation, temperature drops. So with increasing elevation at altitude, the temperature drops by, for every 165 meters increasing elevation, temperature drops by 1 degree Celsius in troposphere. In troposphere, as you move to the higher altitude, that means for every 165 meters increasing elevation, 1 degree Celsius temperature decreases. This is called as the normal lapse rate. This is called as normal lapse rate. I hope it is clear. Okay. Okay. So you can clear that the temperature decreases at rate of 1 degree for every 165 meters of height, and the average around 6.5 to drop in for every 1 kilometer. So 165 meters, 1 degree temperature drops. So the fall of the temperature is called lapse rate, or it's called normal lapse rates. Okay, why? Because the solar radiation, the gases in the atmosphere are not capable of holding the heat from solar radiation. So first Earth's surface gets heated up, okay, and then the heat from the Earth is absorbed by these gases. So that's why in troposphere you can notice here that with increasing in the elevation, you can see the temperature is decreasing. The temperature is decreasing. Okay, I hope it is clear. Then, as I told you, the maximum thickness of the troposphere is maximum at the equator and minimum at poles. Okay. So this is about the troposphere. What you have to remember in a troposphere, with increasing elevation, temperature decreases in troposphere. Troposphere is maximum at the equator and minimum at the poles. Okay, and all the weather related phenomena that takes place in the troposphere. Okay, and then after troposphere, that is, if you take the average, so 0 to 10 kilometers from the surface, so then you have is the stratosphere. So before the stratosphere, there is a boundary line between troposphere and the stratosphere, and it is called as tropopause. It is a boundary between troposphere and stratosphere. The height at which temperature stops decreasing in troposphere. This layer has constant temperatures. So here the temperature may be as low as 58 to 60 degrees Celsius. Okay. So what is tropopause? It is a gap, it is the boundary between troposphere and stratosphere. Okay. Here the temperatures are constant. Now, next moving on to the next layer of the atmosphere, just above the troposphere, around 10 to 50 kilometers, 10 to 50 kilometers above the Earth's surface, you have stratosphere. What you call? You have stratosphere. Okay. It extends up to 10 to 50 kilometers. Okay. So this layer is very dry as it contains little vapor. You know, the maximum water vapor concentration can be seen in troposphere, and as you move to the higher altitude, the concentration of troposphere decreases because all this water vapor will settle on the dust particles and form into clouds. So here you do not find maximum clouds here. So all the clouds, weather related phenomena takes place in troposphere. So that's why stratosphere is almost free from the stormy weather conditions. Okay, and you can see the horizontal movement of air in the troposphere. So this layer provides some advantages for flight. Why? The troposphere is ideal for flying aircraft because there is no weather disturbances, just like for clouds, rainfall and all, because all these clouds are seen up to troposphere only. Beyond troposphere, do not find clouds at max. Okay, so it is very clear, sky is very clear, and you can see the horizontal movement of the air here. So this horizontal movement of the clear weather, steady conditions are ideal for flying aircraft. So that's why, if you remember, if you have an experience of flying in aircraft, you can observe that if you go up, you can see beyond the aircraft, you can see the clouds, because these conditions are stable for flying aircraft. So stratosphere is ideal for flying aircraft because of steady, calm conditions and horizontal movement of air, no clouds and all. Okay, right. Now, one interesting point, if you notice in stratosphere, that in stratosphere with increase in elevation, you can notice that the temperature is once again increasing. So in troposphere, what you see, with increasing in the altitude, temperature is decreasing. That you can notice here. Now, in stratosphere, after crossing the troposphere, in stratosphere, the temperature constantly increases. Now, why this happens? Why this is happening? The reason for this is, with increasing the altitude in the troposphere, the temperature increases because stratosphere, within the stratosphere, around 20 to 30 kilometers range, there is ozone layer. There is ozone layer. O3, ozone layer. In stratosphere, there is a layer called ozone layer, around 20 to 30 kilometers. Now, what happens? So, you all know from where childhood you might have come across this concept that ozone, that there is a layer called ozone in our atmosphere, and this ozone protect us from UV radiation. It protects us from UV radiation, right? So, yes, that is absolutely true. So, there is a layer called ozone layer in stratosphere. So, it protects us from UV radiation. So, sun radiation, there is UV radiation. So this UV radiation is blocked by ozone in the stratosphere. So what happens when this UV radiation is blocked in the stratosphere? All the UV radiation, since it is blocked here, so because of the trapping of this UV radiation, you can see that the temperature increases in stratosphere. Yes or no? So ozone is stopping this UV radiation. So because of this UV radiation concentration in this layer, temperature increases in the stratosphere due to the presence of ozone layer in stratosphere. The temperature increases with increasing the altitude in the stratosphere, right? Yeah. So temperature increases due to the absorption of ultraviolet UV radiation of sun by the ozone present in this layer. Okay. So this increasing temperature with height means warmer air is located over the cooler air. So troposphere you have cooler air, and above that you have warmer air. Okay. So this is about the stratosphere. So what things you have to remember in stratosphere? Stratosphere is just above the troposphere, extending up to 10 to 50 kilometers. And second thing, this layer is calm conditions, horizontal movement of air, and there is no disturbance of clouds or stormy weather. So that's for ideal for aircraft. And third thing is that with increasing the altitude in the stratosphere, temperature increases because of the presence of UV, the ozone layer, which absorbs UV radiation. Okay, so this is about the stratosphere. And above the stratosphere, so there is a boundary line between the mesosphere and stratosphere. The boundary line is called the stratopause. Okay, so just now we discussed the ozone layer is between 20-30 kilometers range, so it absorbs ozone. Okay, right. Mesosphere. So since this, so that's why ozone in stratosphere is good, because it is trapping UV radiation. But if the same ozone, because of the environmental reactions, because of the pollutants, if it takes place in the ground, if there is ozone in the ground level, it is very problematic. It is a greenhouse gas. Then why? Because it has the nature of absorbing the UV radiations. Okay. Next. So mesosphere is found above the stratosphere, around 50 to 80 kilometers length from the above the Earth's surface. You find the mesosphere. Okay. So one more thing, once again in mesosphere, with increasing in the altitude, the temperature drops. Now what is the reason for this? Because when you are moving away from stratosphere, so the influence of ozone is up to here. So by that's why UV radiation, the surrounding areas are warm. But once you are moving away from that region, so obviously the temperature starts decreasing, because there is no heat source above. So mesosphere, with increasing the elevation, temperature drops. Okay, so it extends up to 50 to 80 kilometers. No, so around 80 kilometers area, if you see, the temperature drops up to minus 100 degrees Celsius. So of all the layers, mesosphere is the coldest layer. It is the coldest layer. Okay, so this layer is also known for burning of meteors. Now what are these meteors? Why do they burn? See, meteors are nothing but they are dislodged, they are parts of asteroids. So asteroids are largely seen between Mars and Jupiter. Okay, so these asteroids are remnants of planetary formation. So they revolve around Mars and they revolve around the sun between Mars and Jupiter. Okay, so some parts of these asteroids move in the interplanetary space. So these parts sometimes enter into or come close to the Earth. And you know, Earth is surrounded by atmosphere, mixture of gases called as atmosphere. So when the meteor parts of the asteroid, when they enter into the Earth atmosphere, they start burning. So basically our atmosphere protects us from meteors, asteroids, because once they enter into, after crossing thermosphere, and once they enter into mesosphere, they start burning. So when meteors enter mesosphere, they start burning. Okay, now why mesosphere? When the meteors enter into mesosphere, why only in mesosphere they start burning? Why not in the thermosphere, exosphere? The reason is, as I told you, all the mixture of gases are held by the Earth because of gravity, right? So as you move to the higher layers, influence of gravity comes down, right? So the density of the air is maximum up to mesosphere. So beyond mesosphere, there is no density. There is no maximum density. So that's why, though the meteor comes from the hottest layer, the thermosphere, but it only burns in mesosphere because of density of the air. Because density of the air. So mesosphere, in mesosphere, because of the density of the air, when meteors enter into this mesosphere, because of the friction between the meteor and the air, it start burning. So meteors burn in mesosphere, remember, because of the reason is the meteors burn up in this layer is dense air due to creation of friction between lot of heat. So the upper limit of this mesosphere is between the thermosphere and mesosphere. What you remember regarding mesosphere? Mesosphere is the coldest layer, and this layer is known for burning meteors. And what happens to the temperature in the mesosphere? With increasing the elevation, temperature decreases, right? So above the mesosphere, there is one more layer called as the thermosphere. Okay, so it starts at 80 kilometers and extends up to 400 kilometers. It extends up to 400 kilometers. So this layer is completely cloudless and free of water. Okay, hardly find any clouds in all the cloud related phenomena. It's in stratosphere. So some kind of cirrus clouds you see in stratosphere, but in thermosphere there is no clouds and there is no water. Okay, maximum it can see in this area. So thermo means, you all know, thermo means generally means it's heat. Okay, and the temperature in this layer can reach around 2000 degrees Celsius, very hot. You may get it out. So the temperatures are high here, but why meteors do not burn in the thermosphere? Why they start burning only after entering into mesosphere? Because the reason is, in the thermosphere the density of air is not great. So that means air molecules are widely spaced. So that's why it cannot produce the heat to burn it. Okay, so the why the temperature is high here? Because increasing the temperature due to the absorption of the high energy X-rays and UV radiation in this region. Okay, so because of the high intense radiation in thermosphere region, okay, the layer photoionization takes place, that is breaking of gas molecules into ions. Okay, so these gas molecules in thermosphere, because of high temperatures, they break into ions. Okay, they break into ions. So within this thermosphere, as I told you, because of huge radiation, few X-ray and radiation, the gas molecules break up and get ionized. So there is an ionosphere in thermosphere. There is a layer called ionosphere in the within the thermosphere. Okay, so what is this? So abundant layer of electrons are ionized. They are photoionized. So the breakup of gas molecules into ions. So what is the importance of this ionosphere? So this ionosphere is important because it reflects and modifies the radio waves used for communication and navigation. So we are here. Okay, we send radio waves, and this radio waves reflects back to Earth's surface because of this ionosphere. There is an ionosphere in thermosphere, right? So the radiations, the waves that we send, the communication radiation, it will go to up to the ionosphere and they get reflected back, they comes back. So it helps in communication. It helps in communication. The ionosphere is important because it reflects and modifies radio waves used for communication and navigation. Okay, communication, navigation, radio wave is helpful. Okay, and within the thermosphere range only you have the satellites, international space stations, all these things take place here. Okay, so the ionosphere, the ions, because of this there is an ionosphere, and this ionosphere helps in satellite communication. Okay, then the last layer you have is the exosphere. We have exosphere, it is beyond thermosphere. So this exosphere is the outermost layer of atmosphere, and it extends up to 10,000 kilometers. So basically exosphere nothing but it is space. It is space. So the exosphere contains many of the satellites orbiting the Earth. Okay, and now we have a problem in this area, that because of huge number of satellites from the countries, now the increasing, you are seeing the space debris, increasing of space debris because of the satellites, because the satellites have the artificial satellites have that the satellites we send, it have a time period. After the time period, the purpose of the satellites will be served, and the satellites will no more serve the purpose. So that's why it turns into a debris and they move in the space. Okay, and this debris is increasing. We have this problem. Okay, right. So gradually this sphere makes it into this. So light gases like helium, hydrogen float in this region. Okay, so this is about the structure of atmosphere. This is about the structure of atmosphere. So the temperatures in the land is about 2000 or 50 degrees Celsius. So here the gravity is extremely weak, so that's why the density of the air is less. Okay, so the outer part of it is called as magnetosphere. So if you remember, Earth is a magnet. Okay, Earth is a magnet. So Earth is a magnet. So you might have heard about this term called aurora borealis or aurora australis. Aurora borealis or aurora australis. You know what are aurora borealis or aurora australis? So they are also called as green lights. They are also called as green lights or the northern lights. These lights are only seen in polar or the Arctic Circle region. Okay, so Norway, Sweden, these areas, Arctic and above Arctic region. So here you find green lights in the sky. You find green lights. People go all the way to Norway, Sweden to see these green lights. Now, why these green lights or the aurora phenomena is seen? That too only in Norway and Sweden, Finland, not in other areas. The reason for this is Earth is a magnet. Earth is a big magnet. Okay, and it has a magnetic field. It has a magnetic field. Okay, so in fact this magnetic field of the Earth protect us from intense solar storms. Intense solar storms. Okay, so they are strong. Earth's magnetic field protects us from intense solar storms. So sometimes when there is an intense solar storms, the Earth protects us, the magnetic sphere of the Earth protects us from, but you can see the magnetic lines of the Earth is pointing toward North Pole and South Pole. You can see here, North Pole and South Pole. So when the intense storms of the sun comes, they are directed towards the North Pole and South Pole. They are directed towards North Pole and South Pole where they are intense, very intense. So these storms, when they are directed towards the North and South Pole, these solar storms interact with the gases in that region, okay, and forms into green light. And forms into green lights, we call it as aurora. Auroras. Aurora borealis in the north and aurora australis in the south. Okay, this is about the green lights or green lights only seen in Arctic and polar regions. Why? Because they are interaction between the solar storm and the gases in that region. They appear in green, light bluish in color, green bluish in color. So this is about the structure of atmosphere. So in the next climatology, that is pressure belts. Okay, pressure belts. So students usually have confusion regarding this topic. So all of your confusion will be cleared in this topic. We will detailedly discuss about atmospheric pressure belt in a scientific approach. Okay, right. You know that once again the basic definition, Earth's surface is surrounded by mixture of gases. We call it as atmospheric pressure. The Earth's surface is surrounded by mixture of gases. We call it as atmosphere. Atmosphere. Okay. So this mixture of gases, gases has weight, right? And these gases will exert pressure on the surface. So these gases will exert pressure on the surface, and this is nothing but it is called as atmospheric pressure. Okay, so on the surface of the Earth, a column of the air exerts weight in its term of pressure. So the weight of a column of air, at a given place and time is called as atmospheric pressure. Okay, and the unit we use to measure the atmospheric pressure is millibar. It is millibar. Okay, and the instrument that we use is barometer. Barometer to use the atmospheric pressure. Okay, so what is atmospheric pressure? The weight of the air column at a given place and time surface is called as air pressure or atmospheric pressure. Unit we have, it is millibar. Okay, right. Pressure belts. Okay, so basically we have 7 pressure belts. 7 pressure belts on the earth surface. We have 7 pressure belts in different latitudes on the earth surface. Okay, on the atmosphere. In the atmosphere or on the earth surface based on the latitudes. Okay. So what are the 7? So out of these 7 pressure belts, okay, 3 are thermally induced. That means based on thermal means based on temperature, and 4 are dynamic in nature. 4 are dynamic in nature. 3 are thermal, 4 are dynamic in nature. Okay. So what are thermal, what are dynamic? We will detailedly discuss here. Okay. So before getting into this topic, some basic concept related to pressure. So what is atmospheric pressure? The pressure exerted by the column of air on the surface, a place at a given time and place is called atmospheric pressure, right? So the atmospheric pressure usually either it may be low or high. Atmospheric pressure will be high or low pressure. How it depends on? So simple, generally whenever the temperatures are high, when temperatures are high, okay, the surface heats up and the air above also gets heated up, and when the air or water, when it heated up, it expands. Okay, it expands, and when the air expands, it becomes lighter, and when the air becomes lighter, it will move upward. Okay, so when temperatures are high, earth surface gets heated up and the air above the earth surface absorbs the heat, it expands, becomes light and moves to the higher altitudes. It moves to the higher altitudes. Now when the air moves up, the pressure excited by this air column on the surface will be low. When temperatures are high, air expands and becomes light and moves upward. So the pressure excited on the surface will be low pressure. Now what happens on a chilly winter day? Okay, so what happens on a chilly winter day? Temperatures are low. So due to this low temperatures, the air parcel, instead of expanding, they contract. The air parcels with a low temperature, instead of expanding, they contract. Their weight increases when they contract. Instead of moving upward, they move down. They move downwards. So when they move downwards, the pressure exerted by this air parcel will be high. Okay, so this is the relation between temperature and pressure. So when temperature is inversely proportional to atmospheric pressure, when temperature increases, pressure decreases. Okay, and when temperature decreases, atmospheric pressure increases. I hope it is clear. Okay, right. Right. So I was discussing that we have 7 pressure belts on the earth surface, right? So out of this, I have told you that 3 are thermal induced and 4 are dynamic. So first we will cover the thermal induced things here. So first we will start with equator, very important topic. So equator, okay, so you know that sun rays directly fall on this equator latitude, okay, equator and tropics. So as a result, at the equator, that is equator is nothing but 0° latitude, you all know this, okay, 0 to 5 in north and south. So at the equator, because of direct rays of the sun, temperatures are always high. temperatures are always high. So since the temperatures are high, what happens? The air in the region expands and moves upward, okay. And where do they move? They move up to troposphere. You know that the boundary is the troposphere, and after in the troposphere, after moving the troposphere, they move horizontal, okay. So what happens at the equator? Because of the direct rays of the sun falling on the equatorial region, temperatures are always high, okay. So when temperatures are high, what happens? The air expands and moves upward to the air. So that's why the pressure exerted in this region will be low, okay. So that's why it is called equatorial low pressure belt. So 0 to 5 degrees north and south, 0 to 5 degrees north and south. So this region, because of high intense temperatures, pressure is always low, okay. So the air rising above here in this region will pick up the moisture and give everyday rainfall in this equatorial region, okay. So equatorial low pressure belt. So what is the first one? Equatorial low pressure belt. Then polar region. In the polar region, the sun rays are slanting here. The sun rays are slanting. So because of that, temperatures are low. Temperatures are low. So when temperatures are low, pressure is high. The pressure is high. Okay. So this is north polar high pressure area, and here you have south polar high pressure area. So second, north polar high pressure area, south polar high pressure area. So there are three pressure belts here. There are three pressure belts here. Thermally induced. One equator, two north polar high pressure belt and south pole. So 85 to 90 region here. Latitude region. Okay. So this region. So we have completed three regions here. Equatorial low pressure area and the north polar high pressure area and south polar high pressure area, okay. And next 4 are thermally induced, 4 are thermally, sorry, these 3 are thermally induced, and next 4 are dynamic, not because of temperature but the dynamic factors. Here it is purely because of temperature, okay. So what happens here in this region, okay. So you know that at the equator, because of high temperatures, the air rises above, moves up to troposphere, and as it moves laterally for a distance, so there is no heat of source, so air becomes cool, and the cool air descends at around 30 to 35 degrees, 30 to 35 degrees, 30 to 35 degrees north and south, okay, north and south. So since the air is rising at the equator, moving laterally and descending, okay, you can call it as subsiding or descending. Because of the subsiding or descending air from the equatorial region, this region 30 to 40, 30 to 35 region, it is not tropics, just above the tropics. So it is called as subtropic, and because air is coming from higher altitudes towards lower altitude, so air is coming downwards, so pressure is high, the pressure is high. So this is called north subtropical high pressure belt. This is in the south, you have south subtropical high pressure belt, okay. North subtropical and the south subtropical high pressure belt. So we have completed 2 here. So it is nothing but subtropical high pressure belt, both north and south, okay. Clear? I hope it is clear. And then 66 is around 60 to 65 degree north and south, 60 to 60 degree north and south. So this region is called as, so it's not polar but close to the polar, so we call it as subpolar region. We call it as subpolar region. Subpolar region. Now what happens here at the subpolar region? Okay, so one side at the subpolar region, 6 to 65 regions, okay, the air from polar regions and the air from subtropical region moves towards subpolar region. Okay, the air from the surrounding areas comes here. So at the equator, the dominating factor is temperature. At the polar region, temperature, and at the subtropics, it is the dynamic factor is subsiding or descending air. Now, what happens at the polar region? There, here at the subpolar region, there is a dominating force that is called the centrifugal or the outward force. Okay, the outward force. That means the earth is a rotating body, right? So rotating body has an inward movement and outward movement. So here at the subpolar region, the air outward movement is dominant feature. Outward movement is dominant feature. So that's why the air from the tropics, subtropics and the polar region, the air accumulates here. Due to the whirling effect, the air move upward. The air move upward. Okay. So the outward force is maximum. So subpolar regions in the north and south, here we find low pressure area because air moves upward because of the centrifugal force. Okay, outward movement. So by this we have completed subpolar low pressure areas. So 7 pressure belts you have completed. 3 are thermal. What are they? At the equator, temperatures are so low pressure high, so temperatures are high, so air moves up, low pressure. And polar regions, temperatures are low, pressure is high. Simple. Next, dynamically, subtropics, the air rises at the equator and subsides at the subtropics in the both regions. So because of that, the temperature, irrespective of the temperature, pressure is high because of the subsiding air. Dynamic factor, not temperature here. Dynamic factor is subsiding air. And at the subpolar regions, at 60 to 65 region area, here the air from the tropics and the polar region comes here, and because of the outward movement of the earth, because of the whirling effect, air moves outward, causing a low pressure area over there. Okay, so total we have 7 pressure belts: equatorial low pressure belt, subtropical high pressure belts in north and south, subpolar low pressure belt in north and south, and polar high pressure belt in north and south. So total 7 pressure belts. Okay, so in this pressure belts, if you check in this region, if you check the millibars here, so it is low, and in the subtropics and polar region, it is high. The belt around 30 to 35 degrees here, 0 to 5 degrees here. Here you find a common pressure. So that's why we call them as pressure belts. Okay, and purely this is because of majorly temperature in 3 areas, and at the rest of the 4 areas it is dynamic factor. Now we will try to cover the topic winds also. Always remember, winds always move from high pressure area to low pressure area. Winds always move from high pressure area to low pressure. Just like how we move from high crowded areas to low crowded area, winds always move from high density area to high pressure area to low pressure area. Okay, right. And earth, you know that earth is a rotating body. Earth is a rotating body. So since because of the earth rotation, a force is generated that is called Coriolis force. Due to the earth rotation, a force is generated that is called Coriolis force. So it deflects long moving water, the ocean water or winds towards right in the northern hemisphere. Deflection. Okay, since it is a rotating body, can find deflection, and in southern hemisphere they are deflected towards left. Okay, so because of the earth rotation, the long distance moving winds and ocean water are deflected towards right in the northern hemisphere and left in the southern hemisphere. Why this deflection? generally if you are throwing a ball, okay, if, let's say I am throwing a ball facing at you, okay, so if I throw a ball, there is high chance that ball may direct it towards you, okay, but if I rotate, if I rotate here and throw a ball directing towards you, it will not reach you, it will deflect, right? Same thing here, the air is a rotating body, the earth is a rotating body, so the long distance moving air or ocean water will deflect towards right, okay, one side deflection, let's say right, and opposite side, if this is my right, when I turn here, this will be left, so that's the same thing, there is deflection, so it is right in the northern hemisphere and south in the left, okay, right. So winds always move from high pressure area to low pressure area, and you know this. So this is high pressure area, this is low pressure area, equator is a low pressure area, subtropics high pressure area. So winds has to move from high pressure area to low pressure area, that's it, right? Yeah, right. But you know that there is a concept called, just now I told you that there is a concept called Coriolis force. It deflects the wind towards right in the northern hemisphere and south in the left in the southern hemisphere, okay. So they have to be deflected towards right, right. So if I am moving from equator to poles, if I am moving from equators to poles, this will be my right, right. But now the winds are coming from high pressure, that means pole to equator, so this will be my right, right, this will be my right. So winds are deflected towards right here, so they have to move like this, they will directly deflect because of Coriolis force. So winds always move from high pressure to low pressure area, so they are moving from subtropical to equator area, they are moving straight, but because of the Coriolis force they get deflected, So Coriolis force what, if you are moving from equator towards poles, they will be deflected towards right, and if you are in northern hemisphere talking, in the poles, if you are coming from poles to equator, they basically reflect towards left, okay. So they are lifted, right. So a set of winds are generated here between subtropical high pressure area to equatorial low pressure area, and they are moving from, this is east, right, this is west, okay. So they are moving from east to west, they have to come straight, but because of the deflection they are moving from east to west, okay. Winds are always named after the place they origin, the side they origin, okay. So where they are originating in east and moving towards west, so that's why here the winds which move from subtropical high pressure belt to equatorial low pressure belt, that is from 30° latitudes to 0° latitude, the winds are called as easterlies, okay. The winds are called as easterlies. The winds are called as easterlies, okay. Easterlies. So these are in the tropical region, so they are called as tropical easterlies, or they are also named with the name called trade winds. Tropical easterlies are with trade winds, okay. Now once again, so this is, you have subtropics, it's in high pressure area, subpolar it's a low pressure area. So winds always has to move from high pressure area to low pressure area, something like this, right. But there is a Coriolis force. So if you are moving equator to poles, if air is moving from poles towards equator, they will lift it towards left, and if they is moving from equator to poles, it is moving from equator to pole area, so it has to deflect towards right, okay. So the winds will deflect like this, okay. So which direction it is? West, it is east, so winds are moving from west to east. Winds are named after the place they origin, so where they are origin? West, so they are, the winds are called as westerlies, okay. And then this is high pressure area, this is low pressure area, winds has to move from high pressure to low pressure like this, okay. But There is Coriolis force. Coriolis force, when you are moving from poles to equator, the winds has to move towards left. So they will move left like this because of the Coriolis force. Okay. So where they are originating? East, moving towards west. So there the winds are called as easterlies, but this time they are in the polar region, so that's why called as polar easterlies. Okay. So we have three set of permanent winds or planetary winds. Permanent, primary or planetary winds. Three names: primary, planetary or the permanent. Primary, planetary or permanent. 3 P's. There are three winds: tropical easterlies, westerlies and polar easterlies. So there are three set of winds. They blow in same direction throughout the year. So that's why they are called permanent, and their influence is planetary. So entire planet. So there you can see same planetary winds and primary winds. Okay. So here three winds: tropical easterlies, westerlies and polar easterlies. So tropical easterlies move from east to west. They move from east to west. East to west, and the winds always bring rainfall on the eastern side of the continents, as they bring moisture and give rainfall on the eastern side. So they move from east to west in the equator and tropical region. Then westerlies, they move from west to east in the 30 to 60 degree latitude, and they always give rainfall on the western margins. Okay. And the tropical easterlies, they move from east to west, so largely give rainfall on the eastern side. So which direction they are moving? In that opposite direction, the winds where they are starting, they will give rainfall, and opposite side won't. Okay. So tropical easterlies move from east to west in which latitudes? 30 to 0 degree latitude area. And now subtropical high pressure belt to subpolar low pressure belt, westerlies move between, that is 30 to 60 degrees west to east, they are called westerlies. And then 60 to 90 degrees north latitude, you find polar easterlies. Same thing will happen in the southern hemisphere as well. Okay. So three winds. Okay. And one more point related to this, we have completed pressure belts and planetary winds or permanent winds or primary winds. What are they? Tropical easterlies, westerlies and polar easterlies. Now one more point is, so there is a set of air circulation between these latitudes. We call as cell. We call them as cell. How? Look at here. So, and what is happening at the equator? The winds are rising, okay, and moving laterally, subsiding at the tropical region, okay. And once again, the winds are moving from, in the subsurface, they are moving from subtropics to equator. So you can see that air movement is a cycle here. Okay, this is a cell, one cell here. Okay, and same thing, the air is subsiding here and the moving. Then the at ground level, you can see the westerlies are moving here. The wind is rising, and once again air comes here. So there is one more cell here. Okay, so you can say that is headless cell, feral cell, and same circulation. Air is rising here, will descend here and comes here. It is called polar cell. Okay, polar cell, feral cell and Hadley cell. So Hadley cell is between tropics and equator, feral cell is between subpolar and tropics, and polar cell between polar and subpolar. Okay, three topics we have covered: pressure belts, three winds, and also the what you call the cells, tricellular circulation, air circulation. Okay, and then one more point. So equatorial region, equatorial low pressure area is called as doldrums. Nickname doldrums. What do you call it? Belt of calmness or doldrums. Okay, and the subtropical region, latitude 30 to 35 degrees, is called as horse latitudes. Horse latitudes. Why they are called horse latitudes? Because when horse was one of the famous trading commodity because it was used in wars and other agriculture activities. So when ships used to flow, when ships used to travel in the other latitudes, they used to get the air support, okay, horizontal air support. But when the ships used to get into this subtropical region, 30 to 35 region, so there was no horizontal air movement. So ships used to get stranded. That means they used to stop because of lack of any air support. So in order to make the ship lighter, they used to dump the horses. For trading purpose, they used to carry horses, right? They used to dump the horses. When the ship becomes lighter by sailing, they used to move from that area. So that's why it's called horse latitude. Now it is not, they do not do it because we have steam engines, and here horse we do not carry now. So this is called horse latitudes. Okay, right. So this is about the pressure belts, wind system, and the what do you call tricellular circulation of air. So let's now check the notes here. First, so equatorial low pressure belt 0 to 5, okay, because of high temperatures air rises, and because of this you have a low pressure area, and it is called belt of calmness, belt of doldrums or belt of calmness. So equatorial low pressure belts because of high temperatures. Then you have subtropical high pressure area around 30 to 35 degrees. Why this is happening? Because of the subsiding air, because of the subsiding air from the equator, okay. So these areas have high pressure, this is called horse latitude. And then the subpolar low pressure belt, so 60 to 65 degree, 60 to 65 degree north, okay, 60 to 65 degree north and south. So here because of the centrifugal force, the outward movement of the air, this belt air rises up, okay. So you may get a doubt, sir, centrifugal force is also acting on the equator polar region. Yes, it is acting equator, subtropics and polar region. But there are other dominating factors. At the, for example, at equator and polar region, it is low temperatures, okay, and at the subtropics, descending air is the dominant factor. So at subpolar region, there is no dominating factor except the centrifugal force. So that's why the air moves outward, okay. So that's why this region always experience the cyclonic activity because of outward movement of air, okay. Then the polar pressure belts, this region at 85 to 90 degrees, this region has low temperatures and high pressure. You know that air, cold air is dense, it sinks down and it has more weight, okay, right. So that is the thing. And then as I told you, the equatorial low pressure area, subtropical high pressure area, subpolar low pressure area, polar high pressure area. So from equator to air move from high pressure area to low pressure area. So they move like this, east to west, so easterlies, and then westerlies, west to east. Then you have tropical easterly that we have covered. And the air circulation between tropics, equator and polar region, it is called Hadley cell, okay. And from subtropics to subpolar region, Ferrel cell, and subpolar to polar region, polar cell. So this is the global atmospheric air circulation, okay. So Hadley cell, Ferrel cell and polar cell, same thing concept is here, okay. The wind system. So wind system on the earth's surface can be divided into three groups. One is the permanent or the planetary winds, they are also called as the primary winds, which can see they have the global effects. And then you have the second set of wind, that is seasonal winds. Seasonal winds change their direction according to the season to season, you can also see their effect in seasons. And then you have the third set of winds, local winds, very specific to that particular area, either they may be hot or cold wind depending on the nature of the land, climatic conditions of that place, okay. So wind system. So as I told you, we have three types: primary, or we call it primary, or we also call it as permanent or planetary winds. Secondary winds are also called as the seasonal winds. Tertiary winds are also called as local winds. Okay. So primary winds, just the class, before the class we have discussed, the last class we have discussed about these winds, right? The trade winds, they move from east to west direction, east to west direction. The westerlies, they move from west to east direction. The trade winds move from 0, trade winds are nothing but the polar easterlies, 0 to 30, and they move from 0 to 30 to 60 and 60 to 90. You have polar easterlies. 3 set of winds. The tropical easterlies are trade wind, they move from east to west, and westerlies, they move from west to east. In the polar easterlies, they move from east to west in the polar region, 60 to 90. In 60 to 30 degrees, westerlies move from west to east. 0 to 30, trade winds, they move from east to west. Okay. These winds not only they move from the particular direction. For example, if you take easterlies, they push water from the east to west towards the west coast of the land, whereas the westerlies move from west to east, right? So they push water towards the east coast of the land. Okay, same polar easterlies, they move from east to west and they push water towards the west coast of the land. Let us see, this is a land, piece of land. So they are pushing water towards east coast of the land. Let us say here is the land. So here they are pushing towards water towards west coast of the land. Okay, likewise. So trade winds, they move east to west direction from 0 to 30 degrees latitudes, you know this. Okay, they move from subtropical high pressure area to equatorial low pressure. Winds always move from high pressure to low pressure area. Alright. Then westerlies move from the subtropical high pressure area to subpolar low pressure area. They move from west to east direction. Okay. So these westerlies, when you see 30 to 60 degrees, 30 to 60 degrees latitude, you can the land mass is more dominated in northern hemisphere when compared to southern hemisphere. In southern hemisphere, after 30 degrees, majorly what you find is water bodies. What you find is just water. Okay. So in northern hemisphere, when the westerlies winds move, they are obstructed by land mass. So their velocity will be low when compared to southern part. What happens in southern westerlies region? Beyond 30 or 40 degrees latitude, there is no land mass here. So winds move with great speed, since there is no obstruction. So that's why these winds are named. So the westerlies are more constant and stronger in southern hemisphere because there is no large land mass to interrupt. So that's why they are called as roaring 40s, 40 degree latitude, furious 50s in 50 degree latitude areas, and streaking 60s. Okay, so roaring 40s, furious 50s, and streaking 60s. Roaring 40s, furious 50s, and streaking 60s in the particular latitude areas. Because there is no land mass, they move very fast. Okay, then polar easterlies, they move from east to west. So they move from subpolar low pressure area to polar high pressure area. High pressure area to low pressure area, they move from east to west. They are called polar easterlies. Trade winds are called tropical easterlies. So try to answer this question, 2011 prelims question. So pause it and try to answer. Westerlies in southern hemisphere are stronger and persistent than in the northern hemisphere. Why? Southern hemisphere has less land mass as compared to the northern to north. So westerlies are southern hemisphere stronger. Why? Southern hemisphere has less land mass as compared to northern hemisphere. True, northern hemisphere land mass is high, southern hemisphere land is low. Then the second question, Coriolis force is higher in southern hemisphere compared to the northern hemisphere. No, Coriolis force is same both in northern hemisphere and southern hemisphere. Only thing is direction is different. Coriolis force right, in southern hemisphere it is left. Okay, so second statement is wrong, only one is correct. Okay, so this is about the planetary winds. Now moving on to the seasonal winds, the second type of winds. Seasonal winds are also called as the periodic winds. Okay, yeah. Why periodic winds? Because they change their direction according to season to season. They change their direction according to season to season. So, best example for this secondary winds or the seasonal winds is monsoons. Monsoons are best example for the seasonal winds. Why? Simple. Okay. So, you know this is Indian Ocean, this India landmass. Okay. So, generally June to September, this picture here we let us take example of June to September, and here let us take example of October, November. So, you know that in the month of June the vertical rays of this sun fall on Tropic of Cancer, and India, the Tropic of Cancer passes through India. Okay. So, the landmass, since the direct rays of the sun here fall on the Tropic of Cancer in the month of June 21st. So, temperatures on the land will be high. Temperatures on the land will be high because the sun rays are directly falling the landmass. Okay. And when you are taking the Indian Ocean, the direct rays are not falling directly in this region. Compared to the landmass, the nature of land, it heats up quickly, cools down quickly. But ocean water takes more time to cool down, more times to gain heat. Okay. So, the landmass temperatures are high. So, since the temperatures are high, you know what type of pressure it develops? Low pressure. Okay. And in the ocean water, it is cool. So, it develops an high pressure area. It develops an high pressure area because compared to the land, ocean water is cool. So, winds always move from high pressure area to low pressure area. So, June to September, winds are moving from ocean towards land, ocean to land. So, winds, when they move from ocean to land, if they are warm winds, they pick up the moisture in the ocean and give rainfall. Okay. So, June to September, winds are moving from ocean to land. Okay. And they bring moisture and give rainfall. So, that is why June to September we receive rainfall. Okay. Good amount of rainfall. And the second case, if you see October, November, what happens? The vertical rays of the sun shift towards south, down south. So, temperatures on the land will be low. Okay. So, when temperature is low, pressure will be high on the land. But compared to that, now ocean water is warm now. Compared to that, ocean water is warm. So, when warm water, pressure is low. Winds move from high pressure area to low pressure area. Okay. That means they are moving from land to ocean. Here they are moving from ocean to land. So, in the October, November, the winds are moving from land to ocean, right. So, you can see that there is a shift of direction of winds, change in the direction of wind. They are moving from ocean to land, June to September, and they are moving from land to ocean in October, November period. So, you can see that there is a winds changing their direction season to season. So, these kind of winds are called periodic winds or seasonal winds. Okay. So, this pattern of winds moving in the Indian Ocean was identified by Arabs. Okay. And they initially gave term Monsoon. Okay. And then it turned into a word called monsoon. Monsoon is nothing but it is a seasonal reversal of winds. Monsoon is nothing but seasonal reversal of winds from season to season. Okay. This is the best example of seasonal wind. And another examples also you can say, take example of land breeze and sea breeze is also a periodic wind. How? Okay. During the daytime temperatures are high. So, land, the nature of land, it heats up quickly. So, when temperatures are high, low pressure develops on the land. So, when compared to the ocean takes more time to heats up and cools down. Compared to that, still the ocean water is cooler. So, it develops in high pressure area. Winds always move from high pressure area to low pressure area. Okay. So winds are always named after the place they origin. So they are origin from sea, so it is called sea breeze. You are seeing sea breeze in the daytime because winds will move from ocean to land. In the night time what happens? Temperatures on the land will decrease. When temperatures on the land decrease, it develops an high pressure area. Now in the ocean, now temperatures are still warm, so it develops a low pressure area. Winds move from land to ocean. Now this is called as land breeze. Land breeze and sea breeze. Okay, so this is sea breeze in the daytime, land breeze in the night time. Okay, so that means cool breeze is coming from sea, warm air is moving towards the ocean. Then night time, cool land breeze is moving towards the ocean and warm air is coming from the sea. So you can see that change in direction of winds here, season to season, day and night, periodically, day and night. So sea breeze and the land breezes are also example of a seasonal winds. Okay, so that's why the fisherman in the night time they move towards the ocean, and in daytime they will come towards the land to use the breezes. Okay. Then mountain valley, you also see this in mountain valley, mountain breeze and valley breeze. So in the daytime what happens? Because of the high temperatures at the top of the mountain, low pressure area develops, and the valley still it has high pressure area. So winds move from valley to top, so it's called valley breeze. So that's why if you are a cycling person, mountain cycling person, in the daytime you can easily move towards the top of the mountain using the valley breeze. Okay. Now in the night time what happens? All the heat is lost and a high pressure is developed at the top of the mountain, and comparatively low pressure is in the valley region. So mountain breeze goes up in the night time. Okay. Right. So this is about the example of land breeze, sea breeze, monsoons and breeze are all because of the periodic or the seasonal winds. So periodic winds, these winds keep flowing periodically. For example, land breeze, mountain breeze, valley breeze, monsoons in India, these are all examples of seasonal winds. Okay. Local winds. So these winds are purely local, they are called also tertiary winds. That means they only blow in particular period of the day in a small area. Okay. For example, Lu, Mistral, Phone, Boron. These are all, they are different local winds in different parts of the continents. So they are all example of local winds because they move in only in that particular region. Okay. So these local winds, you can see here the Hamilton, Sirocco, Pampero, Northern, Levant, Phone, okay, Bigfielder, Southerly. So we will be discussing very important local winds of these regions. Okay. So first we will divide the local winds. Local winds can be divided into cold dry local winds and the warm hot dry local winds. Either these local winds will be cold or warm. Okay. And if you are talking about warm and hot dry winds, these winds will be of two types. These winds can be of two types. Warm, hot or dry local winds can be of two types. Okay. How? Hot dry winds, these winds can be directly come from deserts. Okay. The winds which come from deserts are hot winds, that is for sure. Okay. For example, if you say Lu is the hot dry wind coming from Thar desert. Similarly, there is also a wind called Sirocco which comes from Sahara desert, which is an hot dry wind. This everyone is aware of. Second type of hot dry wind is the leeward wind. The leeward wind. What happens? See, generally the winds which are coming from the ocean, they hit the mountain. If there is any mountain, they will hit that mountain. So the winds will pick up the moisture and they will hit the mountain. and when they hit the mountain, these moisture laden winds will rise. They will rise, and when they rise, what happens? All the vapor which is there, it will turn into small water droplets, settle on the dust particles and form thick dense clouds. And when these water particles increases in size, they fall as the rain. Okay, so the moisture laden winds, when they hit the windward side of the mountain, they form clouds and give rainfall on the windward side. And by the time the wind reaches the other side of the mountain, it becomes dry and hot. It becomes dry and hot. Why it becomes dry and hot? Because all the moisture is lost, giving rainfall on the wind side, and by the time it comes, it becomes dry, and when it moves down slope of the movement, because of the pressure, okay, it turns hot. So originating of the leeward side of the mountains, due to the adiabatic heating of sinking of air, it moves top to valley. Okay, so leeward side is always, wind is always warm and dry. Okay, so best example for them is Chinook, Fohn and Zonda. This we will discuss. Okay, the cold winds. Cold wind can be of two types. Either they may be coming from the polar region, or the second category, high mountain areas in especially winters. Okay, so the blizzards are the polar region winds which is coming from the cold polar region, and Mistral, Bora, Pampero, these are originating from the high mountain region. So first we look into the local winds in North America. Okay, of all this is Chinook is important. Chinook is very important of this northern. Apart from that, you have blizzards, Northern, Norte, Santa Ana. Chinook. First we will start our thing with Chinook. Okay, so Chinook meaning is snow eater. Chinook meaning is snow eater. Okay, now why it is called snow eater? See, simple. This is North America, and here you find you have a set of mountains called as Rocky Mountains. Okay, Rocky Mountains. So what these Rocky Mountains do? The winds coming from the ocean, this is Pacific Ocean, the winds coming from the Pacific Ocean pick up the moisture, give rainfall, form clouds and give rainfall on the windward side, western side of this Rocky Mountain. And by the time these winds reach eastern time, they become dry and hot, leeward wind. So basically, Chinook is the leeward wind of Rocky Mountains. So you know that this region comes in the temperate latitudes, above 30 degrees, 40 degrees region. So this region in winters will be covered with snow. So now Chinook is a leeward wind of Rockies. Okay, leeward wind of Rockies. So since now this wind is warm and hot and dry wind, it will clear the snow in the regions. Snow in this region, because it's a leeward wind, it is dry and hot. So it will eat the snow in this region. So that's why Chinook is called snow eater. It is called snow eater. So Chinook, it means snow eater, warm and dry wind, beneficial wind, keeps the grasslands of the east of Rockies free from snow in the winter. So it blows along the eastern slope of Rockies, and western slope they are moist. Okay. Then you have blizzard. Blizzard is a wind which is coming from the cold polar region. So blows in Canada, USA and Siberia region. The Norte is a strong cold wind, blows in Mexico along the Mexico region, cold wind, Mexico region. Santa Ana is also warm, dry, strong wind, flows in the Great Basin. That is, Santa Ana flows in the desert area. There is a great Mojave or the Great Basin desert here. This way coming from this region is the Santa Ana. Okay, Chinook is very important in this. Then moving on to South America, there is another set of wind called as the Zonda wind. Same, what is Chinook for in North America, Zonda is in South America, same. So in South America, you have a set of mountain here called as Andes mountain. Okay, so the winds coming from the Pacific region hit the mountain region, give rainfall on the western side or the windward side. By the time it comes dry and becomes hot and dry. Okay, leeward wind. So Zonda is the leeward wind of the Andes. Okay, So it's a zoned as a warm dry leeward wind flow in the Argentina and Uruguay slopes here in this. Same, then one more wind there is called Pampero, southwestern wind. It is a cold wind, blows in Argentina and Uruguay, cold wind, because it is in temperate region. Then European winds, two winds, Fohn and Mistral are very important. Okay, Fohn and Mistral are very important. Other than that, you have Levante, Bora and Etesian. Okay, Fohn. So Fohn is a strong, dry, warm wind. Why? Because it blows along the northern slope of Alps. Okay, there is an Alps mountain, right? A chain of mountains here in the Alps. It extends in France, Austria, this region. So the Alps mountains. So their alignment is west to east, whereas we have seen Rockies are north-south alignment, right? Here you have the local wind called Alps. So you have mountains called Alps, which extension is west to east, not northwest. So what happens? The winds coming from the Mediterranean region, okay, will give rainfall on southern slopes. Okay, and by the time it reaches the north, region, okay, they become dry. Just like how you have west east, right? Westward rainfall, east side dry. Same thing, southern region, southern side they will give rainfall, and by the time it becomes dry and hot. Okay, and the north slope of Alps in this region, they grow grapes. Okay, so this the hot dry winds helps in the grape cultivation in this region, because in winters these are extreme, right? So strong dry wind, beneficial wind affects the snow, makes the weather pleasant and keeps the early ripening of the grapes. So blows along the northern slope of Alps. See, then there is one more wind called Mistral. Okay, it's a very cold wind coming from the slopes of the mountain regions of, in winters in the mountain regions from Alps. Okay, so very cold dry wind from the mountain regions of Alps, they flow towards Mediterranean Sea, and they are very harmful because they are coming from top of the mountain, they are very chilly, great speed. And Levant is a most moisture drainy wind, blow near the Mediterranean region, pick up the moisture, that's why they are damp. Then you have Bora, it's a cold dry gusty wind, blows in Adriatic Sea region near to Italy. Then Etesian, it is also a strong dry wind, blows in Aegean Sea. Okay, then next the African winds, Sirocco is very important here. Okay, Sirocco comes in Hamartan, these winds are very important in Africa. Okay, so first starting with Sirocco. So Sirocco is a desert wind. You know that there is a big largest desert, that is Sahara Desert. Sahara Desert is located in the northern part of Africa. Okay, northern part of Africa. So what happens here in this region? It's a desert area, so obviously the wind coming from the desert area will be hot. Okay, so Sahara Desert is morely a sandy desert in the area. So the Sirocco wind which moves from the desert, the hot dry wind which moves from the desert area, also carries the desert sand with it. Okay, and it pick up between Europe and Africa. There is a sea called Mediterranean Sea. So the Sirocco wind along with the dust pick up the moisture in the Mediterranean Sea, and it gives rainfall in the southern Europe. Okay, in Italy, Spain, this region. Okay, they give rainfall, and this rainfall is in color of red color. It is called blood rain. Why? Because Sirocco is carrying the dust with it and pick up the moisture in Mediterranean region and give rainfall in the Europe region. So it is called blood rain. So warm, dry, dusty wind, also known as the blood rain, because of its reddish and sand brought along with the Sahara Desert, and it is very destructive for the crops in that region. Okay, so it blows in the northerly direction of Mediterranean region, so Italy and Spain. Then there is one more wind called comes in, same Sirocco in the desert, Sahara Desert, so comes in the sandy desert in Egypt. blows in Egypt and Red Sea. So this Sirocco blows in Mediterranean Sea region, right? So here it comes in Sirocco. Both is hot and dry wind originating from deserts. So it flows in Egypt, Red Sea region comes in. And then Habub. Habub is a wind, violent storm winds, and blows in North Africa and do not have any specific direction. Okay. Then you have another wind called Hamerton. There is a wind called Hamerton, dry, dusty, northeasterly trade wind. Okay, dry, dusty, northeasterly trade wind. It blows from Sahara Desert over the West Africa. It blows from the Sahara Desert over the West Africa. Now, this Hamerton wind is called doctor wind. It's called doctor wind. Why? Because see, the equatorial region, this region is always hot and humid, and the Hamerton which is coming from the desert area is a dry wind. Okay, so here the equatorial region, it is dampy weather conditions, right? So it is air is full of moisture. So when humidity is high, right? So when the dry air which has no moisture, when this air meets this region, the humidity, the water vapor spreads, and it will give a relief kind of thing. So that's why Hamerton is called doctor wind here. It is a dry wind moving into dampy regions, so it has a moderating effect in the West Africa region. Okay, so what we covered here, Hamerton is a dry, dusty, northeasterly trade wind. Arrival of Hamerton makes the weather pleasant suddenly in the western coast. Therefore, it is called doctor wind, because before coming arrival of this Hamerton, it is completely humid, sticky weather. So once it comes, it makes the weather pleasant. Then you have Berg. Berg is also a wind in South America, African name of fohn wind. A hot dry wind blowing from mountainous to the interior coast. So they blow in the Kalahari desert area. So it obviously hot dry wind. Then in Asia, you have two winds, that Buran and Kara Buran in the Central Asian, North Asian region. So they are hot dry winds, of course. And apart from that, you also have Yoma in Japan, hot dry wind. You have Simon in Saudi Arabian desert, Lu in the Thar desert. All are hot dry winds. Okay. So Buran, in summer it's hot dry wind in this region, and winter it is cold because of blizzards. Then Kara Buran, a dust laden fast blowing winds, blows in Central Asia. Simon is a strong dry dust laden winds because it blows in Arabian desert. Then Yoma is also a warm dry desert in Japan. Lu, it's a hot dry wind in northwestern India. Okay. Then moving on to the local winds in Australia, Brickfielder and Southerly. Southerly move from south to north of Australia, that means coast of Australia, and Brickfielder is coming from the coast to the ocean. Okay, it's a hot dry wind in South Australia. So this is about the local winds in the world. Okay, so we have covered the tertiary, the permanent winds, then we have covered the seasonal winds, and then we have covered the local winds. Okay, so in the next class, what is global climate classification, how it is done, okay, and what is the importance of this, will be detailedly covering in this topic. So in each climatic zone will be dealt in detail. It's about the temperature pattern, the rainfall pattern, and the vegetation in this region. Okay, so yeah, so global climate classification. So the climatologist Vladimir Köppen, Köppen has divided the world climatic into 5 regions. One is the hot humid zone, hot zone, okay, warm temperate zone, cool temperate zone, and polar zone. Okay, so what is hot humid zone? Here is we find the equatorial type of climate. Let me show you the picture. Yeah. So equatorial zone, hot zone, okay, warm humid zone is this equatorial zone, the hot wet equatorial climate, then hot zone, warm temperate, cool temperate, polar temperate. Okay, so 0 degree to 10 degree latitude area, you have hot wet equatorial type of climate. Okay, and above 10 to 30 degrees latitude area, on the west of the continents you find deserts, central part you find savanna and Sudan type of climate, and on the eastern side you find monsoon type of climate, and 30 to 45 degree area you find Mediterranean type of climate. In central part you find steppe type of climate, and on the eastern part you find China type of climate. And 45 to 60 degrees north region you find, on the western side you find British type of climate, central Siberian type, and eastern you find the Laurentian type of climate. And 65 to 80 region around you find tundra type, and beyond that latitudes you find ice cap mountains. So this is the Köppen's climate classification into 5 zones. Okay, so we'll detailly discuss about each zone and climatic conditions. In prelims they repeatedly ask about this question. Okay, so hot and humid zone, hence we find the equatorial type of climate in this 10 degrees. Then hot zone, monsoon, savanna, desert type doesn't come here. Warm temperate, the China type, Mediterranean type of climate comes here. Cool temperate, British type of, Laurentian type of climate, polar region, taiga, tundra region. Okay. So first we'll start with the equatorial region, the hot, wet equatorial region. Okay. So the hot, wet equatorial region, you find equatorial rainforest here. So here you know that the equator, the direct rays of the sun fall in this region. The direct rays of the sun fall at the equator, 0 degree latitude, 0 to 510 degrees latitude. Okay, since the direct rays of the sun fall in this region, this region is hot. Okay, and it also has the subsequent water bodies in this nearby water bodies in this region. So hot air rises up, pick up the moisture in the daytime, and by the evening 4 o'clock, 5 o'clock, torrential rainfall take place for a limited period of time. So every day this will be the scenario in the equatorial type of climate. Because of the the direct sunlight of sun, temperatures in that region rises up. So warm hot air pick up the moisture from the nearby water bodies, rises, and around 4 to 5 it give rainfall. So this is a common phenomena at the equatorial type of climate. Equatorial region do not have any climate of region. Every day is almost same, with same climate. Every day it rains almost in 365 days, 300 days it rains in the equatorial region. So that's why you find thick dense vegetation in this region. Thick dense, and for the forest you find here is equatorial region. Okay, the equatorial hot wet climate found between 5 to 10 north and south of equator. So the greatest extent is found in the Amazon rainforest. Okay, the Amazon rainforest, the Ituri rainforest of the Congo basin. This is the Amazon basin, you find this in the Congo basin, and the Harpen rainforest here, especially in the Southeast Asian countries. Okay, Indonesia, Malaysia, these regions. Okay, Thailand. So these are the rainforest region. The Amazon rainforest, the Congo basin of Africa, and the Indonesia, Malaysia regions of Asia. This is the region you find the greatest extent of this equatorial forest, Amazon, the Congo, the Malaysian, East Indies areas. Okay, so temperature. So temperatures, if you see at the equator region, you see great uniformity throughout the year. You can see, if you see the temperature, every month is almost same. There is no big difference in the temperature. Okay, and rainfall, every month is in the rainfall, June, February, March, April, May, June, July. Of course, in June, July, little rainfall comes down, but every day you can see rainfall. There is no month that there is no rainfall here. Okay, so the mean monthly temperature is always around 27 degrees. There is no winter. Every day is same. And cloudiness and heavy precipitation moderates the daily temperature. Though this equator region receives direct rays of the sun, temperatures are not high as in deserts, because every day there is rainfall. Every day there is rainfall. Okay. Precipitation, every day there is 100 inches of rainfall. There is no month without rainfall I was talking about. Okay, and the natural vegetation here you find is the tropical rainforest. Okay, the Amazon, just now I shown you the Amazon basin region. The Amazon forest in this region is called as selvas. The rainforest regions of Amazon are called as the selvas. And here you find evergreen forest. Okay, since this region receives everyday rainfall because of the convection current, that means because of high temperatures, the air rises above, collecting the moisture, gives rainfall every day in the evening. Okay, and since there is good rainfall, there is a thick dense forest, and there is competition among the trees to grow tall because of the sunlight. For the competition of sunlight, trees go tall in this region. Okay, and the most common type of tree species that you see here is ebony, mahogany, rosewood. These are the tree type of trees that you see. Ebony, mahogany, rosewood are the most common type of tree types you see, and you find herbs, shrubs, short trees, dense canopy, and tall trees in this region. Okay, and in this region, what you can see is heavy rainfall, dense forest, evergreen forest. That means trees do not shade their leaves at a same time. Okay, okay, and then in this region, the soil in this equatorial region is not rich in nutrients. Because though this region is rich in forest, the leaves, when they decompose in the soil, they don't completely decompose because of heavy rains. The nutrients are washed out. Okay, so the high temperatures and the moisture of the tropical rain forest cause dead organic matter in the soil to decompose quickly. Okay, they don't remain in the soil, they decompose quickly. High temperatures and humidity conditions, they do not decompose, and they decompose quickly. So nutrients are always less in this region. Okay, so leaf litter decomposes faster than in any other biome. Okay, this region is rich in trees, so these leaves, when they fall on the soil, they quickly decompose because of hot, humid and high temperature. That's what I am saying. So leaf litter composes faster than in any other biome. As a result, the soil is often almost bare. Apart from trees, the vegetation is largely composed of plant forms that are reach up to the canopy, as I told you, dense, climbing the trees, and you also find epiphytes in the trees. Epiphytes, a plant which grows on the other plant. Okay, soils in the tropical rainforest are typically nutrient poor. Why? Because the high temperature, high moisture in the soil, when the leaves fall, litter on the soil, they quickly decompose because of high temperature and high moisture. Okay, so the dead organic matter in the soil decomposes quickly. So as a result, then soil loses nutrients. Okay, and whatever the nutrients that are left over, that will be washed out by the running water of the rain. So that's why soils in this region are infertile. Now you can solve this question. The soils in the tropical rainforest rich in nutrients? No, right? The soils in this region is not rich in nutrients because the litter particle that is there quickly decomposes. So first statement is wrong, second statement correct. And here they have given the big statement here and asking to find out which forest it is. So leaf litter decomposes faster because high temperatures and high humidity is seen in this region. You can see epiphytes, a large vegetation you are seen. So this mostly suitable for which? Coniferous, dry deciduous, mangrove, tropical rainforest is the answer here. Okay. Now try to answer this question. Each day is more or less same. The mornings are clear, bright, with a sea breeze. Okay, and sun climbs high in the sky, heat mounts up, dark clouds form, and then it rains. Rain comes with thunder and lightning, but it is soon gone. That means, so just now we have discussed it, right? What happens at the equatorial region? Because since it is the sun rays directly fall at the land, okay, because of this temperatures are high, the air becomes lighter, pick up the moisture in the nearby areas, rises up, okay, forms clouds, and in the evening 4 o'clock or 5 o'clock it rains. Okay, evenings it rains. This is everyday phenomena. In which type of climate? That is the question here. In which type of climate? Equatorial type of climate. Right. Which of the following are unique characteristics of equatorial forest? Presence of tall, closely set trees with crowns forming a continuous canopy? Yes, trees grow tall and they form canopy, okay, shadow kind of thing. And coexistence of large number of species, yes, here you find different type of species, shrubs, herbs, small and tall trees. Presence of numerous varieties of epiphytes and then trees growing on trees, yes, you find this. So 1, 2, 3 are the characteristics of equatorial type of forest, okay. So when you talk about this resources in the equatorial region, so these are thick dense forest, but in tribal areas, they are following the shifting cultivation. What is shifting cultivation? Simple, they cut down the forest. So it is practiced in hilly terrain areas by tribal communities. They cut the forest, okay, cultivate it in the region for 2 to 3 years, and after 2 to 3 years the soil will lose its nutrients, and when the soil loses its nutrients, they will shift to another area, okay. This is called shifting cultivation, and this is not good because once you cut the trees, it takes years to grow the same kind of forest, okay. So shifting cultivation, the zoom cultivation, in Telugu it is called podu cultivation. This type of cultivations are not good for forest because forests are cleared and it is good for cultivation, okay. So bellucas in Malaysia, Singapore, Indonesia are the secondary jungle forest that grows after clearing the land. So after clearing the land in cultivation, bellucas are the second generation forest that grows after that, okay. Coming to the resources in this region, it is a thick dense forest area, okay. What do you call, lumbering is not a great profitable activity because different type of tree species grow in a small area. So you cannot, if you want to cut some X tree, you have to cut other trees. So it's not an profitable area. Lumbering is not profitable. So this region is very backward region, still it is backward. But when the European countries like Britishers started to colonize the tropical areas, they have seen that, they have found that the rubber, this area is suitable for the growth of rubber, okay. The coconut, sugarcane, tea, tobacco, bananas, pineapple, these are the tropical or the equatorial type of climate suitable for this type of thing. So with the coming of Europeans, many large plantations have been established, especially in Java, Sumatra, Malaysia, West Africa and Central America, the equatorial region, okay. Plantations of palm trees are seen in Malaysia, Indonesia areas, sugarcane in Brazil, coffee in Brazil, rubber in Malaysia and Indonesia, and cocoa in Ghana and Nigeria. So the chocolate is made up of this cocoa, Ghana and Nigeria. So these are the plantations and the region. So in the examination, they may give the list and ask you to match, or they will give this, is this pair correct or wrong, okay. So as I told you, lumbering is not suitable, okay, because there are multiple type of tree species grow here, and the tree type that here you find is hardwood. Hardwood is not easy to move, whereas in the temperate and polar region, what you get is softwood. It can be easily chopped off and carried, okay. And climate is very harsh, yellow fever, malaria, these are common type of in regions in endemic to this region, okay. And the people who live in this region are primitive people, practice the civic cultivation. So you can see the Congos, the pygmies of Congo region, Congo basin of Africa, and the orang aslis of Malaysia. So these are the tribal groups that you see in the equatorial region, because equatorial region is not suitable for dense population because you have dense forest surrounding area and climate is very harsh. So that's why only few tribal groups live in this region, okay. So Congo basin pygmies, and in Malaysia you find orang aslis in this region, okay. So coming to mineral resources in this region, natural resources in this region, you find sulfur in Mexico, tin in Malaysia, mineral oil in Indonesia and Venezuela, bauxite in Guyana coast of these countries, okay. So that is about equatorial type of climate. What you remember about, what are the points that you have to remember in equatorial forest? Everyday rainfall, no winters, every day is almost same, okay. Temperatures are almost throughout the year. Since there is everyday rainfall, there is a thick dense growth of forest, okay. And though this region has thick dense forest, though they have huge amount of litter every day, the soils are not rich in nutrients because these soils, because of high temperature and humidity, quickly they decompose, okay, and whatever the nutrients that are left, they are also leached away because everyday rainfall. So soils are not rich in nutrients, and this region is known for growth of rubber, cocoa, coconuts, tea and coffee, and this is also famous for the tribal communities in Congo basin like pygmies, Orangaslis in Malaysia. Okay, that is about equatorial type of climate. Then moving on to tropical monsoon or tropical marine type of climate. So distribution of the tropical monsoon, it is found in the zones of between 5 to 30 degrees area. They are found in 5 to 30 degrees area. Okay, 5 to 30 degrees, 5 to 30 degrees area. So the dark shade color that you are seeing is tropical marine type of climate, and the light shade color is tropical marine type of climate regions that you find here. Okay, so just now, just before the class, we have discussed what are monsoon. Monsoons are nothing but the seasonal shift of winds to season. So these are the areas of the tropical monsoon lands with onshore wet monsoon in summer and offshore dry monsoons in winter. You know this. Just now we have covered in the previous topic that June to September months, what happens? The temperatures, the vertical rays of the sun fall on the Tropic of Cancer. So Tropic of Cancer passes through India. So temperatures are high on the land. So it develops a low pressure area. And compared to that, ocean water in the Indian Ocean, temperatures are low. So winds always move from high pressure to low pressure area. So they are moving from ocean to land. Onshore winds onto the shore, moist land and onshore winds. Then October, November, what happens? The vertical rays of the sun differs down south of India. So land temperatures in October, November decreases. So pressure will be high, and the ocean water temperatures all warm now. So winds move from high pressure to low pressure area. That means here they are moving from land to ocean. So this offshore winds are dry. Offshore winds are dry in winter, and in summer onshore winds are wet. Okay, so onshore wet monsoons in summer and offshore dry monsoons in winter. So it is well developed in this region, India, Bangladesh, Burma, Thailand, Cambodia, this region. You can see the monsoon effect. Okay, this is because of heating and cooling of the landmass in this region. Okay, so the seasons of tropical monsoon type of climate, here you find the cool dry season, hot dry season, the rainy season. Cool dry season, October to February, no rainfall, temperatures are cool. Hot dry season, March to mid-June, no rainfall but high temperatures. And the rainy season, mid-June to September. Okay, so you can see cool dry season where temperatures are cool but there is no rainfall. In winters, you can see there is no rainfall. Then in mid-June, June to September, there is rainfall. And then rainy season, June to September, rainfall is there. That is about the monsoon type of climate. And the forest you see in monsoon type of climate is deciduous forest. The trees which shade their leaves in dry period. So most of the forest that you find in monsoon type of climate is deciduous type of forest. And within the same latitude, apart from monsoon type of climate, you also find marine type of climate. You see onshore trade winds. Okay, so trade winds move from east to west. In 0 to 30 degree latitude areas. Right, trade winds move east to west in 0 to 30 degree latitude areas. So these trade winds, if you remember, they give rainfall on the eastern margins of the continent. Okay, so in this case, a type of climate develops that is called tropical marine type of climate. Okay, and the type of forest you find here is tropical deciduous type of forest. Okay, so trees are open, they are not that lush green as case, dense in case of the evergreen forest. They are open and less luxurious, and the timber in this region is valuable because these trees are not dense, they are placed with gaps. Okay, so this, especially the teak is a teak, sal, sesame, hurrah, these are the more common type of common tree species that you see in monsoon type of climate, and they are of great value. And when it comes to economy in this region, since this region has a seasonal pattern of rainfall and it has good plain batches area. So it is largely known for cultivation of paddy. India and China, these areas. So it is India is the second largest producer of rice in the world, and this region, the tropical type of climate, is also suitable for the growth of sugarcane, coconut, cotton, spices. So that's why India is known for cotton and spices production. Okay, and then it is also known for cash crops. Okay, like jute, and in highland areas in the same tropical regions like in Western Ghats and this region, you find coffee cultivation. Okay, so the Ethiopia Arabica are the types of coffee seeds that are largely grown here in this region. Tea, highland areas of India also tea, you find tea cultivation, and lumbering is a profitable area because trees are not that dense. And the hilly areas of this region suffer from same problem, shifting cultivation. Okay, so that is about the tropical monsoon or marine type of climate. Then moving on to the tropical savanna. Tropical savanna or the Sudan type of climate. Okay, so the tropical savanna or Sudan type of climate, here what you find is you find trees here and there, and majorly you find grasslands. Okay, in savanna type of climate. Now why do you find grasslands? Simple. Okay, so you can see the red patches region is the savanna type of climate or Sudan type of climate. So basically Sudan comes under savanna type of forest, so it is also called as Sudan type of climate or savanna type of climate. Now in this there are tropical grasslands, tropical regions, the grasslands that you see in tropical regions. Okay, so why you find grasslands in this region? Because you know that if you just now we have seen tropical marine type of climate, they give rainfall only in the eastern margins of the continent. They give rainfall only in the eastern margins of the continent. So what happens? The trade winds which blow from 0 to 30 degrees, they give rainfall on the eastern margins of, they pick up the moisture in the ocean and give rainfall in the eastern margin. By the time the winds move to the central part, they become dry. So they do not give great rainfall. Okay, so they give moderate rainfall, and by the time they reaches western part, no rainfall. So only moderate rainfall is you get in the central part. Maximum rainfall is seen in the eastern margins. Okay, so because of this region, here you find only grasslands. Okay, you find grasslands like this. And you can also find extreme diurnal range of temperature since they are located in interior parts, no moderating effect of sea and land breeze. So interior parts, so temperatures, diurnal range of temperature is also high. Okay, and here you see a wind called Harmattan, doctor wind, where thus we have, because it brings pleasant weather conditions in this region, Harmattan is called doctor wind. Okay, and the natural vegetation is very important. So there is a very tall type of grass that grows in this region, is called as elephant grass, up to 15 feet. So it is called bushveld and parkland. Okay, you can see that the grass which grows up to 15 meters height. And the trees you find here and there is the acacia. This is the tree, most common tree that you see in this region is acacia, and tall grass up to 15 feet. Okay, and the type of vegetation, the trees are deciduous, shading their leaves in cool and dry season. Okay, and in certain areas you find trees, tall big trees called baobabs. So these areas, trees store their water in the trunk. Okay, especially to protect themselves from dry areas. And this savanna type of grassland that you see, the tall grass that you see is nothing but savanna, tropical grassland. So it's a big game country for wild animals. So here you find ostrich, jackal, African elephant, hyena, the cheetah, zebras. Okay, so if you remember, recently a couple of one and a half year ago, we have brought these cheetahs and introduced in India. Okay, in Kuno National Park of Madhya Pradesh. Cheetahs got extinct in India, so we bought cheetahs and introduced in the Kuno National Park of Madhya Pradesh. we brought it from here. Okay. So this is about the savanna type of grasslands. Savanna are nothing but tropical grasslands. Why this region is grasslands? Because the rainfall, they are in tropical region. In tropical region, only eastern margins get good rainfall. By the time they come to the central part, rainfall is moderate. So that's why here you find tall grasslands, and here and there you trees like finds like acacia. Okay. So here coming to the economy, the two tribal groups grow here, live in this region, that is the pastoralists like Masai and settled cultivators like Hausa. So Masai tribes and Hausa. Hausa you find in Nigeria region, Masai in the Central African region. So these are the tribal groups that you see in this region. So Masai tribes are dependent on cattle rearing. Okay. So they use these cattle for milk and blood. Milk and blood. So milk obviously they get it from the cows, and blood also they will get it from clouds. They take the bad blood from the cow and have it. Okay. So this is about the Maasai tribes. And then you have the mineral resources in regions here. So bauxite is largely seen in Jamaica, that is in the islands of West Indies, and then copper in Katinga Plateau of Jair region is in Africa. So this is about the mineral resources in this region. Okay. Coming to this region, though the animals, they grow largely, the Maasai tribes grow cattle rearing. They do cattle rearing like this. But you can see that cows are very weak in this region. You can see. So the cows that you see in Hatson curd ad, they are very hefty. Each cow looks like a buffalo. But here you can see that the size of cows are very weak in tropical region. Why? Because the grass here is dry grass, not green grass. Okay. And the cows suffer from the diseases like sleeping sickness, CC fly effect. So that's why dairy is not that efficient in this region. Okay. So we have covered the equatorial forest region, then the monsoon and marine type of climate, and then we also discussed the the savanna type of climate. Okay. So now we will move on to the desert type of climate. So the deserts are seen on the western margins of the tropical region. So distribution of tropical desert. So desert is an area with scanty rainfall. Hot desert is a region with high temperatures and scanty rainfall. Cold desert is a place scanty rainfall but with low temperatures. So the polar regions are nothing but cold deserts. Okay, hot deserts and you see in the western margins of the tropics. So you can see around 30 regions of each continent. On the western side you find deserts. Okay, 0 to 30 degree latitudes. On the western side of the continent you find deserts. Now why you find these deserts here? The reason is you know that the easterlies which blow 0 to 30 degrees north and south. So these winds blow east to west direction, and they give rainfall only on the eastern margins of the continent. The central part it is less, and by the time they reaches the western side, these winds become dry. So that's why the western margins of the continents are dry region. You find deserts. So you find Mojave Desert in North America. Okay, the Atacama Desert in South America. Okay, the Sahara Desert in the Africa, Kalahari Desert in the Southern African region, and the Great Australian Desert in Australia. All are located on the western side. Apart from this, you also find mid-latitude deserts, not tropical deserts. Patagonia Desert because of the Andes, okay, and in central region, the Turkestan and Gobi Desert. So all the tropical deserts are on the western side of the continent. Okay. Why? Because the easterlies bring only on the eastern margins rainfall. Rest of the time it is dry. So rainfall it is very high. So rain bearing trade winds blow offshore. Though the direct rays of the sun falls on the equator region, equator is not the highest temperature recorded region. Why? Because equator region there is everyday rainfall. So tropics, so though the direct rays of the sun fall on the equator, equator is not the highest temperature recorded area. It is the tropical deserts are the regions which receives the highest temperature, because there is no rainfall. So temperature intensity will be more. Okay. So the driest region, the highest temperature regions are recorded in the Azizia, a place called Azizia in Libya, 58 degrees Celsius. So hottest spots on the earth at high temperature throughout the year are deserts, not equator region. Though equator receives high intense solar radiation, temperatures are low because everyday rainfall. In deserts, temperatures are high and there is no rainfall. Okay. So that's why since there is no rainfall, you find xerophytes. Okay. The bushes like this, and you find cactus like shrubs. Okay. You find what you find here in this desert is xerophytes. What you find in equatorial region, epiphytes, trees growing on trees. Okay. And palm trees here and there, palm trees. Okay. So you can see this is water, plain water areas. Okay. So life in deserts, you find Bushmen in the the Kalahari Desert, Bindubu in Australian, Gobi Mongoles in Gobi Desert, okay, Beduins in the Tuaregs of Saharan Desert, and Gobi Mongolian, Bedouin Arabian. So these are the groups, tribal groups you see in this region, desert regions. Okay. So, and you can also see that wherever there is cold current in that region, you find deserts also, that we will discuss in ocean currents part, because only if you understand that part you can understand this. Simple reason, wherever there is cold current, no, wherever there is cold current, there is a desert beside that, because when there is a cold current, water will also be, the air above it will also be cold. So when the air is cold, what happens? It cannot hold moisture, bring rainfall. Only warm air can hold the moisture and bring rainfall. So each desert area there is a cold current. California current to Mojave, Peruvian current near to Atacama, Canaries current to Sahara, Benguela current to Kalahari Desert, okay, West Australian current to the Great Australian Desert area. So these cold current areas, the air about the cold current will also be cold, so they cannot pick up moisture and give rainfall. And by the easterlies only give rainfall on the eastern margins, so that's why they remain as deserts. Okay. And minerals, if you see the white water stand of Kalahari Desert, it is famous for gold, diamonds, Kimberley of Kalahari Desert, crude oil in Arabian deserts, so copper in Chile, nitrates in Atacama Desert, and silver in the Sonoran Desert. So now we have completed the hot wet equatorial type. What is the common points in the hot wet equatorial type of climate? Everyday rainfall, lush green vegetation, ebony, mahogany, rose gold trees that you find here. Okay. There is no winters, every day is almost same, and soil do not contain nutrients. Though they have dense forest, the leaves that litter will not add into organic matter because they quickly decompose and washed away with the rain. So soils are not fertile, everyday rainfall. Then we have covered the monsoon type of climate, eastern margin type of climate. So seasonal reversal of winds takes place. So here you find deciduous type of forest, and this region, since this region has vast plain areas suitable for cultivation. And in the central part of the continents, you have savanna, 0 to 30 degrees, 10 to 30 degrees, savanna type of or southern type of climate. Basically, you find grasslands, tall grasslands, okay, famous for wild animals. And then we have discussed the hot deserts, which are located on the western margins of the continent from 10 to 30 degrees latitude area. These regions, because the trade winds give rainfall on the eastern margins, and on the western side of this, beside the hot deserts, you have the cold currents. So cold currents means water will be cold, cold area, cold air cannot bring rainfall. So hot deserts are seen on the western margins of the continent from 10 to 30 degrees. And hot deserts, what you find is xerophyte, bushes, cactus, okay. Here and there you find palm trees and oases. Okay. So this is about the hot zone. Now we are moving to the next zone, that is warm temperate zone. The warm temperate zone where we will be covering Mediterranean region first. Okay, warm temperate Mediterranean type of climate. Okay, so warm temperate Mediterranean type of forest. So it is found in few areas of the world. You can see it is well developed in the surrounding areas of Mediterranean type of climate. So that's why it is called Mediterranean type of climate. But actually, the actual name is warm temperate western margin. Warm temperate western margin type of climate. Okay, so you find in Mediterranean region, the Californian region, the central Chile, the western Cape of South Africa, and southwest and South Australia. Okay, since this type of climate is the European countries, which when they colonized, since this type of climate is available, they have, that's why they have colonized the South Africa continent, the country, Australian, okay, Chile, California, these are all Europeans settled there in this region because of the same type of climate. Now, what is the Mediterranean type of climate? So these are the Mediterranean countries, very important for map pointing as well. So Morocco, Algeria, Tunisia, Libya, Egypt are the South African countries which share border with Malaysia. Spain, France, Italy, okay, Greece, Slovenia, these countries have Mediterranean border of Europe. Right. Climatic conditions. So the climatic conditions of this region is that you know that the pressure belt shift towards north in the month of June and they slightly shift towards south in the month of December, because it all depends on vertical rays of the sun. So vertical rays of the sun falls on in the month of June, so towards north. So pressure belt slightly shift towards north, 5 degrees towards north. And when in the month of December, the pressure belt slightly shift towards south because the vertical rays also shift towards south. So this is the position, and March and September they will be in the same position. So what you can see is this, what you are seeing is the offshore winds, dry offshore winds. These winds are moving from land to ocean and they are dry because they are carrying no moisture. Okay, in the March. Now in June what happens? Same things. These winds are also, this area, the Mediterranean region is also under the influence of the trade winds. They are moving from east to west. So they are moving from land to ocean. No rainfall. Same September also. No rainfall. So this region, it does not receive rainfall in March, September or in the June month because winds are moving from land to ocean. No rainfall. But in the month of December, what you saying? They since the pressure belts move south, the wind patterns also moved little south. So now you can see that the Mediterranean Sea is under the influence of westerlies. They are under the influence of westerlies. Now the westerlies move from west to east and they bring rainfall on the western margins of the continent. So these regions receives rainfall in the winter. So Mediterranean type of climate, they receive rainfall in the winter. Winter rainfall is the unique feature of Mediterranean type of climate. Okay, so a concentration of rainfall in winter with onshore westerlies. Rest of the months it is offshore trade winds, but here there is onshore westerlies rainfall here in this region. Okay, so they get rainfall in this region. So you can see Rome, Italy, Mediterranean type of climate, so the rainfall is in October, November, December, winter. Cape Town of South Africa, the maximum rainfall is also seen in winters. So that means in south, you know the differences. When it is summer in the north, it will be winter in the south. When it is summer in the south, it will be north in winter, winter in the north. So climatic conditions, Mediterranean climate are near large bodies of water, so temperatures are generally moderate because they are close to water body. Since they receive winter rainfall, okay, and the wind that you see here is the Sirocco. We have just now we have discussed the local winds. So the Sirocco winds bring rainfall in Italy, Spain, and the rainfall is called blood rain because Sirocco is a hot dry wind, pick up the moisture in the Mediterranean Sea and give blood rain in the Italy and Spain. Okay, and this region, since they receive rainfall in winter, trees with small broad leaves are widely spaced and never very tall. Since they receive winter rainfall, trees are not very tall and they are widely spaced. This is the Mediterranean type of forest that you see. Okay, and this is most suitable for the cultivation of, here you find the pines at the higher altitude regions of this plate, and lavender, okay, rosemary, laurel. These are type of shrubs you see in this region. Okay, and lavender, rosemary are used for making perfumes. So olive tree, rosemary, lavender shrubs, laurel, these are all seen in the Mediterranean type of climate. Okay, so cultivation, this climate is suitable for cultivation of citrus fruits. Okay, orange, grapes in this region. So that's why, and they use these grapes for viticulture, for wine making. In Mediterranean region, they grow grapes for wine making. Okay, so each region has got particular name. For example, South Spain wine is called sherry, Portugal wine is called port wine. Okay, Chianti and Asti are the parts of Italian different parts of wine. So this, remember, Mediterranean region is known for citrus fruits and wine, wine cultivation. The grapes grown used for making wine is called viticulture. Viticulture, remember. Okay, and since this Mediterranean region type of climate, they receives winter rainfall. Summers are bright sunny weather with dry summers and wet mild winters. Because of this, they are important tourism spots, tourism countries, Portugal, Spain, Italy, Greece. So these are all, they attract tourism from different parts of the world because of its bright summer and mild winters. Okay, mineral resources, coming to mineral resource, petroleum is highly seen in the Signal Hills of California, zinc and lead in Brooklyn Hills of Australia, bauxite is seen in France, mercury in Italy. Okay, so now we have completed the Mediterranean type of climate. Now we will move to the steppe or the temperate grasslands and then move to China type of climate. Yeah, so temperate type of climate, the temperate continental type of climate. So cool temperate, western margins is nothing but that we have seen, that is the Mediterranean type of climate. Now the cool temperate continental type of climate is steppe, or it is steppe. So steppe, temperate grasslands. So what happens here? The steppes, you can see the temperate grasslands, very important, the temperate grasslands, that is 30 to 45 degrees region, temperate grasslands of North America are called as prairies. The temperate grasslands of South America are called as pampas. The temperate grasslands of Europe are called as steppes. In Australia, it is called pustas. Okay, and the same temperate grasslands in Africa is called as veldts. Okay, the temperate grasslands in Australia are called as downs. The temperate grasslands in New Zealand are called as Canterbury. Okay, so the temperate grasslands in North America are called as prairies. The temperate grasslands in South America are called as pampas. The temperate grasslands in Europe are called steppes. In Austria region, this is called pustas. And the temperate grasslands in Africa are called as veldts. The temperate grasslands in Australia are called downs. The Canterbury grasslands in New Zealand. Okay, right. Now, why do you find grasslands in this region? Simple. So, the Mediterranean region gets rainfall because of westerlies. Western side, this is nothing but here. So, this region, the westerlies, Mediterranean region receives rainfall through good rainfall because of westerlies, and these parts are in the central part of the continent. So, they receive moderate rainfall. They receive moderate rainfall. Always the central part receives moderate rainfall. So, so that's why rainfall is not great. So, the trees do not grow, but it is certainly helpful for the growth of grasslands. So that's why you find grasslands in this region. Okay. So in the North America prairies, pampas of South America, welds of South Africa. Okay. So these prairies are full of grasslands. So they are lush green. You can see they are tall, fresh and nutritious. So that's why they are suitable for pastoralism. Okay. So the steppe is in the Central Asian region. The main economic activity was nomadic herding. So nomadic herding, that means in olden days what they used to do is they used to carry the animals along with them. Okay. Wherever there you find the grass patches, they used to feed them and move to the another area. Nomadic herding. So they used to roam along with their cattle. Okay. So this nomadic herding herds people. Nomadic herding in the region were called as Kyrgyz, Kazakhs, Kalmuks. So Kyrgyz, Kazakh, Kalmuks were the Central Asian nomadic herding tribal groups. Now present day, these countries are named after this tribal group. Kyrgyzstan, Kazakhstan are nothing but they were the earlier tribal groups of this region. Okay. Now with the, since this is known for good grasslands, plain areas, especially in North America, they are used extensively cultivated for wheat cultivation. Extensively they are used it for wheat cultivation. Okay. So that's why the grasslands of North America is called as the bread basket of the world. Bread basket of the world. So yeah. And here since this region you have good grasslands, large vast patch of grasslands, ranching is also practiced. So what is ranching? It is a practice of raising herds of animals in large tracts of land, and this is controlled by a cowman. It is called ranching. Okay. And since this region is suitable for growth of grass, they have removed the natural grass growing in that region and they are growing alfalfa. Alfalfa is a grass which is rich in nutrition. Okay. So this grass sits in nutrition. You can see how the cows are here. Each cow is very hefty. Okay. That the same cows that we have seen in the tropical grasslands, they are very weak, right? The cows, the cattle rearing of Maasai tribes. Why? Because the grass is not nutritious and they frequently suffer with diseases. And here in the temperate grasslands, grass is tall, nutritious. So that's why you can see the cows are very big and giving the milk, and they also use it for beef production. And apart from that, in Australia, the sheep are also grown. The wool that is extracted from this sheep are called merino wool in this region. Okay. Then moving on to the eastern margin of the temperate, warm temperate region, the China type of climate. So the China type of climate resembles most like a monsoon type of climate in this region. So moist summer, onshore trade winds. So this China type of climate can be is also called as the Gulf type of climate in North America, Natal type in South America and South Africa, China type in China region. Okay. So these are eastern margins, temperate in warm temperate region, eastern margins you find this type of climate. Okay. So this climate is nothing but modified form of most of the part China and modified form of monsoons. Okay. So climatic conditions in this region, as I told you, good rainfall during summers, and this region is also frequently affected by cyclones. These cyclones also bring rainfall in this region. Okay. So in the lowlands, deciduous forest is seen, and in the highlands you can see the pine trees in the region. So oak, camphor, camellia is also seen in this region. Walnut, oak, maple are also grown in long areas. And here a type of pine trees are grown that is called Parana pine, quebracho, which is hard as axe. So that's called the axe breaker. In Paraguay, Uruguay you find this, and you also find rich palm trees in South Africa. Eucalyptus trees in Australia. Okay. So Economy, coming to this economy, since they are same to the monsoon type of climate, wet paddy lands are seen in this China, famous for rice cultivation, and Yangtze river, Hunger river basins. And in the hilly regions, they practice terrace farming, tea, mulberry leaves. That is, China is famous for silk. That this mulberry leaves, on the mulberry leaves only the worms thrive, and based on that they fame silk. Okay, corn, cotton, tobacco are also grown in Gulf states. Okay, basically the corn is grown in the Gulf region of America for pigs. Okay, that's they are used for feeder. Cotton, citrus fruits, and in the state of Virginia, the famous for tobacco, that is seen in this region. Okay, in Southwest Australia, it is also famous for dairy. Okay, so once let us quickly revise here about this China type of climate. These points are important. In the southeastern China, what they are growing rice, tea, and mulberry. So extracting silk from mulberry is called sericulture. In southeastern USA, they are widespreadly growing cotton, maize, fruit and tobacco. In South Africa region, sugarcane. In South America region, coffee and maize. Okay, so by this we have completed the warm temperate region. We have completed Mediterranean, steppe, China type. Prior to that, we have completed hot desert, Savana, monsoon. Prior to that, we have completed hot equatorial, and we are left with this British, Siberian, Laurentian, and tundra type of climate. So we will complete this part, and then we will move to oceanography. So the next topic, the next type of climate is the British type of climate. So it is seen in the western margins of the continent. So around 45 to 60 degrees, western margins of the continent, you find cool temperate. So cool temperate western margin type of climate or British type of climate, because it is largely seen in British type of climate. So that is why it is called British type of climate. So 40 to 50 degrees on the western margins, you find this type of climate. Okay, London in Canada, southern Chile, okay, Hobart Island of the Australia. So interesting feature of the British type of climate is temperatures are usually between 5 to 15 degrees, never beyond that. Okay, so hardly temperatures touch up to 18 degrees. Annual range of temperature is small because they are close to the coast, right? So there is no major difference between summer and winter. Okay, summers are moderately summers and mild winters can be seen. Proper 4 seasons can be seen in British type of climate. Okay, so rainy season, spring, okay, autumn, winter. Coming to the rainfall in this region, okay, it is moderate rainfall. You can see that there is every month almost rainfall, and mean temperatures are never below 15 degrees. Temperature is moderate, and you find deciduous forest in this type of climate. So here we have seen in monsoon type of climate, we find deciduous forest. They shade their leaves in dry period, right? Because of lack of water. Here in British type of climate, the trees shade their leaves because the winters are extreme. In order to survive winters, the trees shade their leaves. There is a difference here. Okay. So oak, beech, poplar, hornbeam, elm, willow are the type of trees that you find here. And since same type of tree species grow in large areas, they are good for lumbering as well. And the wood you find here is softwood. Okay, so this region is also rich for industrial advancement because availability of coal, iron ore in the regions, they are rich in industrial areas. Okay, and the areas in the England near to the North Sea, they are also famous for fishing. Okay, they are famous for dairy farming as well. Merino wool is seen in this region. And about agriculture, very key point of this region is market gardening. Since the urban areas are high in this region, so in the nearby suburban areas or countryside, they grow vegetables and fruits that is necessary for the urban areas, and everyday morning they bring in the truck and sell. So this is called market gardening or truck gardening. Suburban areas grow for the needs of the city. Okay, so similarly this at Hobart Island, they grow these products and every day they move to Australia using ships. Okay, so this is about British type of climate. So British type of climate, there are 4 different seasons, every day rainfall, almost but little rainfall. So that's why you never know when it rains in British type of climate. So it frequently changes, the weather frequently changes in British type of climate. So that's why British attire, you can see they always wear overcoat, top hat, okay, and they carry umbrella with them. Then the Siberian type of climate, the central part, this region. So this cool temperate continental region, you find Siberia, tiger and boreal type of climate. So the cool temperate continental climate, it is called Siberian type of climate, or in Russia it is called tiger type of climate. So here you find evergreen coniferous forest. The trees are coniferous in shape, okay, and they do not have leaves. So this type of climate is seen in the central part of the continent, and majorly what you find in this region is, so temperatures are extreme, winters are very extreme, temperatures go up to -40 degrees Celsius. Precipitation is not high, not so great, but trees in this region are coniferous in shape. Why they are in coniferous shape? They are in coniferous shape because winters are extreme, so you find snowfall. So that's why they are in triangle shape. So when snow falls on them, then can easily slide down. Okay, so that's why leaves are of needle shape. This is how they look in winters, extreme winters. So but the trees that you saw, coniferous trees are of softwood for making, used for making paper industries. Okay, these trees are all used for paper industries. And in Canada and central part of Russia, you find this type of animals like moose, red fox, okay, wolverine, grey squirrel, this thing. Okay, the tribal communities in this region earlier used to use the skin. Since the skin is very thick, they used to skin in leather industries. Economy, as I told you, lumbering is a good profit organization because the woods are very soft. They can easily be traveled through the flow of rivers, and they are made for paper industries. So Canada country is known for paper industries in this region. Okay, and Somaites, Yakuts, okay, reindeers, these are all seen in this type of climate. Then moving on to Laurentian type of climate, the eastern margin type of climate, here you find mixed type of climate. So eastern margin, cool temperate climate. So this climate, rainfalls you can see in throughout there, but moderate. Winters are generally cold. Why? Because they receive rainfall because of the trade winds here. Winters are extreme, as I told you. And two important things to be noted, that the Newfoundland area of Canada and the Great Banks of England area and Japan, these places are important because Japan is also continental region. So cold and warm current meet here in this region, so important fishing ground. Same Newfoundland also, a cold and warm current meet. So Newfoundland of Canada and the Japan are known for fishing in this region, fishing. And now Japan is also growing seaweed and the ocean. Okay, then you have last the tundra type of climate. You know, the Arctic or the polar temperate climate, nothing grows in this region because of the extreme climate. What you see is mosses and lichens, like this colorful mosses and lichens, and alpine meadows here and there. So climate is very extreme. They are completely covered with ice most of the period of the year. Okay, precipitation is mainly in the form of snow only, even if it forms in snow. Okay, so the mosses and lichens, sedges are found in this region, and you can see the musk ox, lemmings, Arctic polar bears, okay, penguins, seals, walrus are seen in Antarctic region. In Arctic region you find polar bears, this region. Now the melting of glaciers is a big problem here, because once this glacier starts melting because of global warming, these animals will lose the environment, habitat for their growth. Okay, so Eskimos of Greenland, Alaska, Canada, you can see here, and you can see lapse in Scandinavian countries. Economy in this region, now it is believed to have good resources under this, especially iron, petroleum regions. So that's why the Arctic region is always in news. So there are 8 countries in this region in the Arctic Council. So they form a union year for the development of this region and actual utilization of these resources. Okay, so this completely articles in the snow, but because of global rising temperatures, there is melting of ice. So there is huge competition for this exploration in this area. Oceans. So you know that the earth is called as a blue planet. Why? Because 71% of the earth's surface is covered with water. So oceans are nothing but huge depressions of land where water is stored. Okay, so earth is called as a blue planet because 71% is covered with water, and almost the southern hemisphere is completely water for us. Okay, so no, you know that 71% of the earth's surface is covered with water, but all water is not fresh water. All water is not fresh water. Okay, so the total, if you take the total global water available, 96.5% is ocean water, and ocean water is not a pure water. Why? Because ocean water is saline. Ocean water is saline. What is ocean? What is salinity? Nothing. If you take 1000 parts of, if you take 1000 parts of ocean water, if in this 1000 parts, if the salt content exceeds 33 parts, if the salt content is more than 33 parts in the 1000 parts of water, then it is called as salinity of the ocean. It is called salinity of the ocean. Okay, not that 330, 33 parts. Okay, if 0.3%, no, if 33 parts for every 1000 parts of ocean water, if 33 parts exceeds, then it is called salinity of the ocean. So 96.5% is in the ocean. The ocean is not suitable for drinking water. They are not pure water. Okay, then out of 9 point is saline water, and 2.5% out of all the total water available, only 2.5% is the fresh water. Okay, out of the global water that is available, 95.6% is ocean water, only 2.5% is fresh water. And out of this 2.5 fresh water, 2.5 fresh water, major of the fresh water is in glaciers and ice caps. 68.7% is in glaciers and ice cap. Okay, and around 30.1% is in groundwater. 30.1% is in groundwater, and only 1.2% is in surface freshwater. So out of the total global water available, 96.5% is ocean water. Only 2.5% is fresh water. Out of the 2.5 fresh water available, 68% is in glaciers, 30% is in groundwater, and only 1.2 percentage of fresh water is available in surface, and that too on the surface permafrost covered with ice, 20% in lakes, 3% in atmosphere in the form of water vapor, okay, 3.8% in soil moisture, 0.26% in living things, 0.49% in rivers. Getting my point? So out of this 2.5 fresh water, total fresh water available, 68% is in glaciers, 30% in groundwater, 1.5% in surface, and that too in surface majority part is in once again permafrost, ice, lakes, and only 0.5% is in rivers. So this is about water distribution. And examination they will frame questions like this. With reference to the water planet on the planet Earth, consider the following statements. The amount of water in the rivers and lakes is more than the amount of groundwater. This statement is absolutely wrong, because more water is in groundwater, 30% is groundwater and around 1% is in rivers and lakes. Then the amount of water in polar ice caps and glaciers is more than that of amount of groundwater, true, right? So ice cap 68%, groundwater 30%, and then surface fresh water 1%. So it is a sequence. So second point is correct, first one is wrong. Then on the planet Earth, most of the fresh water exists in ice caps and glaciers. Out of the remaining fresh water, largest portion, so majority is saying that majority of fresh water is in glacier and ice caps, and next majority is in groundwater. Simple. Okay. So majority will be existing in groundwater. Simple. Okay. Then ocean surface features. So ocean, just like how we have mountains, plains, plateaus on the surface, same structures are also seen beneath the ocean floor. Okay. First, the continental shelf. So it is usually the continent part only, but submerged part of continent by water. So this if continental shelf is wide, then it is suitable for fishing, because here this is sunlight, right? So sunlight falls in this region. Sunlight falls good in this region. So fishery is good for fish. So if the continental shelf is wide, is famous for fishing. Okay. The plains, then this abrupt slope is called continental slope. Plains is called abyssal plain. Seamount and islands which are formed by volcano is called as volcanic islands. Okay. So continental shelf, it is wide, it is famous for fishing. Ocean deeps like Mariana Trench, Tonga Trench, these are ocean deeps. You find ridges in the ocean as well. The Atlantic, mid-Atlantic ridge is the biggest one. Okay. Then salinity of the ocean. Salinity of the ocean I have discussed. Salinity is calculated as the amount of salt dissolved in 1000 grams, which is generally expressed in parts per thousand. Okay. Parts per thousand. So the average salinity of the ocean is 3.3% or 33 parts of salt in 1000 parts. 1000 parts 3. Right. Now let us move to the topic ocean currents. Ocean current, most important topic, and students usually have confusion in this topic called ocean currents. Now we will try to detail discuss about the topic ocean currents. Okay. So ocean currents are nothing but large amount of ocean water, they circulate in a particular pattern is called as ocean currents. Large amount of ocean water, they circulate in a particular pattern is called as ocean current. So what is an ocean current here? Ocean currents are large masses of surface water that circulate in regular patterns. It's called ocean currents. So they are very massive movement of ocean water. So ocean currents are of two types. Based on depth, you can divide into two types: surface currents and deep ocean currents. So surface currents are what we see, deep ocean currents are what they are very big. Okay. So deep ocean currents are very big, and surface currents are large scale of surface ocean currents driven by global winds and system. Okay, what we focus on is the surface currents. Okay, and you can also divide the ocean currents into two types: warm ocean currents and cold ocean currents. So warm ocean currents are the ocean currents which come from the equatorial region. They are warm, obviously, tropical and equatorial region. And the cold ocean currents are the currents which come from the polar regions. Obviously, they will be cool. To move from polar to equator region, the cold ocean currents. Okay. So if you look at the ocean, if you look at the world oceans, you can find different types of ocean currents. The red ones are the warm ocean currents and the blue ones are the cold ocean currents. Okay. So these ocean currents are direction is modified by the planetary winds. So easterlies put water towards the western side and westerlies put water towards the eastern side in the continent. Okay. Planetary winds, temperatures, cold ocean currents come from the polar regions, warm ocean currents from the equatorial and temperate region. Salinity, if the density of the water is more, you can see the deep ocean currents maximum. Earth rotation, so because of earth rotation also you can see a force is generated, that is Coriolis force or Ferrel's law. They deflect towards large moving wind or water body towards right in the northern hemisphere and towards left in the southern hemisphere. Okay. The land mass, so whatever the ocean currents they touch the land mass, based on the land mass they change their movement. Okay. Now first we will see, we will look into each ocean current ocean wise, right. So now this is equatorial region, so obviously water will be warm, yes or no. So first we will see the north equatorial current, south equatorial current. So north equatorial current, it moves like this, touch the coast of, and then move to in this direction. This north equatorial current, this is north equatorial current in Pacific region. Okay. So since it is touching the coast of Gulf, this is called Gulf of Mexico, so it is called Gulf Stream. It is called Gulf Stream. Okay. And this Gulf Stream initially, now why this warm water is moving from east to west? Because of the influence of trade winds. So 0 to 30 degrees, they will there will be in the influence of trade winds. Direction will always from east to west, and 30 to 60 degrees they will be under influence of westerlies. They move from west to east. Okay, remember. See, so once this warm water under the using of landmass, they are turning and they move up to here, and then under the influence of westerlies they cross the 30-degree latitude now. So the winds will move, will push the water towards eastern side. So they will move like this. Okay, so this warm current, which is warm water which is there in equatorial region, they are pushed towards the west because of easterlies. So easterlies will put the warm water towards the west and touch the coast of Gulf. So it's called Gulf Stream. So now the water is changing its direction. So that is called North Atlantic Drift. So this is called Pacific Ocean. So it is North Atlantic Drift. So warm water is pushed towards, you can see the Norway, Sweden and Finland. The Norway, Sweden, Finland. Here it is called Norwegian current. Norwegian current. So you know that in the Norway, Sweden, Finland are in the Arctic region. So winters they are very extreme. So you can see the whole ports are frozen in winters. But thanks to this warm current, thanks to this warm Gulf Stream current, which keeps the coast of Norway, Sweden free from ice, Okay, so this we have discussed this in climate, the factors that influence the climate of a region, right? So ocean currents always have effect on the climate of the particular region. So here this warm current is keeping the Norway, Sweden ports from freezing in winter because of this warm current. Okay. So in between, a cold current comes from this region called as the Labrador current. Labrador current. So always remember, whenever a warm and cold current meet, it is an important fishing ground. Important fishing ground. Okay. And see, since all water in the tropics in this region push toward the east, the upwelling cold water comes up. A cold current forms here in this region called as Canaries current. See, all warm water is pushed towards the west coast, right? So below that the cold water will come and form a cold current called Canaries current. There is an island called Canary Island, so it is called Canary current. So wherever there is cold current, there is a desert here. So there is a Sahara desert, remember. So why? Obviously the easterlies will bring only rainfall in eastern regions. By the time they reaches the west, no rainfall, keep the coast dry. So Canaries current, cold current, so cold water, cold air, no rainfall. Okay, so this is the ocean currents in North Atlantic region. Similarly, now the south equatorial current, it is touching the coast of Brazil. Now this current is called Brazilian current. Okay, and slowly comes down. Now under the influence of westerlies, this current will move south. Now there a cold current comes here, in the region flows here. Okay, and the cold current here, it is called as Benguela current. It's a cold current, and you here have a desert called Kalahari desert. So Brazilian current is moving from east to west because of the trade winds. Along the coast it moves down, and once it gets across the 30-degree latitude, they come under the influence of westerlies. They push winds towards west to east. So this water is pushed towards east here. Now the cold current, so the water which is pushed towards the east in the tropical region will comes up and forms a Benguela current, cold current. Okay, this is about Pacific Ocean. Same thing you can see in the Indian Ocean as the Pacific Ocean as well. Okay, so this is a picture here, that is half part and this is half part. So here the warm water pushed towards east to west under the infrared trade winds. The blue angle coast of Japan here. Okay, and here one cold current comes in this region, from this region. Okay, so here the warm current is Oashio, and here a cold current called Kuroshio. Okay, wherever the warm and cold current meet, an important fishing ground. It's an important fishing ground. Okay, same this. Then here a cold current forms here called as Californian current. Californian current, and here you have a Mojave Desert. We have a Mojave Desert. So one circle, Oahu, Kuroshio, and cold current California. In the South Pacific also same thing, you can see warm current, close east to west on the insular trade winds. So here this is West Australia, East Australia, so this is called East Australian current. Okay, then it drifts here. So once here it drifts here, you can see a cold current is formed, that is called Peru current. Peru current or Humboldt current. Cold current, so that's why you have a desert called Atacama Desert here. Cold current. Okay. Now South Indian Ocean. Same. Warm wind touches the coast here. Okay. Here it is called Agulhas current. Agulhas current, Agulhas current, and then you have a west to wind drift, entire west to east, you warm cold water moving here, so drift is the region, and here you can see West Australian current is a cold current, so that's why you find a desert called Great Australian Desert. Okay, one circulation, Agulhas current, West Australian current. And now unique thing about the Indian Ocean current is these ocean currents also change their direction according to monsoons. See, in the terms of summer, the ocean currents are diverted towards India like this. Okay, and in winters the ocean currents are directed away from India. This is the feature of the ocean currents in North Indian Ocean. So this is North South Atlantic, North South Pacific, South and North Indian Ocean. These are the ocean currents. So in exam point of view, what is important? Which is cold current, which is warm current. Okay, and which current is in which part of ocean. For example, Benguela, it is in South Atlantic. California, North Pacific. Okay, Agulhas, South Indian Ocean, and it is a warm current likewise. So this is a picture here. The entire picture I have shown you. You can see North Atlantic, North Equatorial Drift, Gulf Stream, and it is drifting North Atlantic drift toward Norwegian current, keeping the cold. Labrador current, meeting point, important fishing ground, and cold current here forms a Canaries current. Similarly, the Brazilian current, South Equatorial current, Brazilian current, warm current, South Atlantic current, the Benguela current. Then Pacific region, So this, just now I have told you that Kuroshio is a warm current, Oahu is a cold current. I got a little confused. So yeah, so North Ocean current, you can remember that K is used for Kelvin temperature, right? So hot, remember. So equatorial current, warm current is Kuroshio current, and it meets the Oahu current, cold current. So important fishing ground. Japan is an important fishing ground, this point and this region, and then California, cold current flows in this region. Then similarly, in the North Equatorial current, East Australian current, and drift by South Pacific, and you have a Humboldt current here. Okay. Then in Indian Ocean, South Indian Ocean, South Equatorial current, the Agulhas current, and west wind drift, West Australian current, cold current, complete one current. Then the South Equatorial current, the North Equatorial current in the Indian Ocean, they move towards India in the monsoon period and away from India in the dry period, October, November period. Okay, so this is about the ocean currents. So effects of the ocean current, first thing, it has an impact on local climate. So wherever there is cold current, beside that there is a hot desert. Okay, and wherever this warm current moves in the colder regions, that keeps the, for example, the Atlantic drift keeps the North Sea free from ice. Precipitation, as it wherever there is warm current, that region receives good warm rainfall, and wherever there is the cold current, their precipitation is low. Okay, desert formation, wherever there is a cold current and beside that you find a desert, moderating effect. Tropical cyclones, wherever there is warm ocean current, see, whenever there is warm ocean current, when temperatures are above 27 degrees, there is formation of cyclones. So wherever there is warm water ocean current, there is a chance of forming tropical cyclone. And wherever the cold and warm ocean currents meet, it is an important fishing ground, because nutrients upwell. Okay, nutrients from beneath comes out, and it is good for planktons, and plankton is for fish of food. So that's why that region. And navigation, since the ocean currents move in a particular direction, you can use them for navigation as well. So this is about the ocean currents. Okay. Now we will move on to the small topic called tides. Tides. So for world geography, two books are essential. One book is NCERT, 11th class NCERT, Fundamentals of Physical Geography. Fundamentals of Physical Geography is the book, and this is the basic book, and standard books is G.C. Liang. G.C. Liang. For all the physical geography, the topics which are covered are in G.C. Liang, and Fundamentals of Physical Geography, 11th class NCERT. Okay. Right. Next topic, tides. So what is tides? Generally you see in the coastal areas, right? So the alternate rise and fall of water, sea level water is called as tide. The periodical rise and fall of water level in the oceans in once or twice a day due to gravitational pull of the sun, moon is called tide. Okay. So you can see that there is alternate rise and fall of sea level water. Okay. So this alternate rise and sea level water is called tides. And why it happens? Simple thing. Okay. So when it is low, it is called low tide. Okay. Low tide. When it is up, the tidal range is high, that is called high tide. Okay. So the zone between high tide and low tide is intertidal zone. Right. How they occur? So decreasing in the ocean water is called ebb, and increasing is called flood current. Anyways, these terms are not important. Now why tides occur, that is important. So tides occur because of moon's gravitational pull, major one, followed by sun's gravitational pull, and also the centrifugal force acts opposite to the gravitational pull of the earth. These are the three reasons. Moon is major one, also along with that sun's gravitational pull and the centrifugal force of earth which acts as opposite pull to the gravitational pull of earth is also important. How I will explain. So this is sun, this is earth, and what you are seeing is water and the moon. Okay, moon has some gravitational pull, so it can not able to move earth, but it can pull water against it. So moon, it's pulling gravitational water. Yes sir, because of its gravitational force, it's pulling water towards it. So there will be rise in water on one side. Now what happens? The bulge what you are seeing in the water is because of moon's gravitational pull. So earth is also rotating body, it will also have an outward force. So because of its outward force also, the opposite side, one side there is pull of moon, another side because of the centrifugal force, outward force of earth also, water is moving opposite side. Okay, it is moving the opposite side. So you see high tides on two sides and low sides in its opposite sides. Okay. So these are phases of moon. So phases of moon like new moon, Amavasya we call it as, okay, waxing crescent, first quarter, waxing gibbous, full moon. So after new moon day, after every 14 days you find full moon day, and then slowly the size of the moon will decrease. Then you will get a new moon day. So new moon day to full moon day to new moon day, 14 days, 14 days. Okay. Now what I am trying to explain is here, on a new moon day, why moon is not visible? The size of moon actually will not change, but what happens here is light, you only see moon when sunlight falls on it. Moon exists in same shape every time, but we are able to see only that shape of moon because only that part sunlight is falling on the moon. So for example, if you take new moon day, the sunlight is falling on the moon, but we are not facing that part, so that's why it is dark. And in case of full moon day, you can see sunlight is falling on that part and we are able to see that. So it is full moon day. Simple. Okay. So what happens on a full moon day? What happens when the moon is between the earth and sun? Okay. So anyhow, moon has a gravitational pull and it will pull the water along with it. And this water pull is enhanced by sun's gravitational pull. Then it's here. I hope you are able to understand. So moon's gravitational pull is pulling water towards it. So plus in addition to that, there is sun which is also helping the strengthening the moon's gravitational pull to water. So as a result, what you find? You see a spring tide. Spring tide is a high tide when normal high tide, it's not a normal high tide within high tide, spring tide. Okay, so when the position of sun, moon are aligned in such a way that the straight line, that the moon's gravitational pull is enhanced by the sun, so in that case you find spring tide. That means height 20% of higher than normal ordinary tides is seeing, that is a spring tide. Then next, so when moon moves to opposite side, so when moon, earth and sun are in right angle position, this time what happens, the gravitational pull of the moon is not enhanced by the sun, but in fact it acts as a deterrence. Okay, so this case what happens, the low tide will see, ultra low side, no tide, lower than low tide is neap tide, higher than high tide is called spring tide. So usually 20% higher than high tide is called spring tide. When it occurs, when earth, moon, sun are in straight line, spring tide occurs. And when neap tide occur, when the moon is fourth quarter or perpendicular, height of the tide will not increase, it will be low. Okay, so it is called neap tide. So neap tides, after every 7 days, after 7 days spring tides occur, a neap tide occurs when they are in right angles, 20% lower than this thing. So spring tide, 7 days neap tide, then a spring tide, then a neap tide. So this is what happens. Okay, so what is a spring tide? Spring tide occurs when sun, moon, earth are in straight line, aligned in straight line, that moon's gravitational pull is enhanced by sun. In that case, you can see a thing, spring tide, and when they are in opposite under 90 degree, you find neap tide. So that is about tides. Okay, so by this we have completed important topics in oceanography. Okay, thank you.